October 27th, 2025. A privately owned optical instrument detected an anomaly that defies conventional understanding. You're observing celestial coordinates identified as 13 hours, 48 minutes, 57.33 seconds, and -8 degrees, 25 minutes, 54.3 seconds. This precisely matches the location provided by NASA for 3I Atlas. However, this photographic capture, raw and unaltered from a civilian astronomer's solar scope, reveals characteristics that contradict all known cometary physics. It displays an organized structure, a thermal shield directed squarely at the sun, a dark core exhibiting inverted hues, a subtle, cone-shaped exhalation extending in an unexpected direction. And this is the most astonishing detail. There is no visible tail. Every comet cataloged possesses a tail. It is a fundamental aspect of their physical nature. The solar wind propels gas and particulate matter away from the sun, a universal principle. Therefore, what are we witnessing at this very moment? The celestial body currently obscured by our star, the entity approaching at an opportune time for a trajectory adjustment. The source emitting fabricated alloys previously observed only in human-made spacecraft, now photographed exhibiting an impossible phenomenon. Today, we will dissect every piece of evidence, explore every hypothesis, and consider every potential outcome as this entity reaches its closest point to the sun on October 29th. If you find this subject as captivating as I do, please indicate your interest by liking and subscribing. Then, in the comments section, share your geographical location, the current time there, and your honest assessment. Do you believe this is a natural occurrence or something else entirely? To support the growth of our community, please disseminate this information on X, Facebook, Reddit, or via your messaging applications. We deeply appreciate your consistent support. The image that redefines our understanding. This photograph surfaced on social media at 1600 hours Universal Time on October 20th. The user, identified as Dobsonian Power, is an amateur astronomer utilizing a solar telescope. This is not sophisticated institutional equipment, but rather the product of an individual possessing the precise targeting knowledge and the technical proficiency to observe celestial bodies in proximity to the sun, a task that major astronomical observatories have conspicuously avoided. The image depicts 3I Atlas at a distance where it should be demonstrating typical cometary behavior. We are discussing an object that has been journeying towards our sun for months, presumably heating up, releasing gases, and forming the characteristic tail that all comets develop as solar radiation causes surface ice to sublimate. This tail should be readily apparent, prominent, and oriented away from the sun, akin to a banner in the wind, due to the fundamental laws of physics governing our solar system. Yet, this is not what is observed. The image showcases a jet emanating from the front. The poster described it as a heated shield. This jet is directed precisely towards the sun, not away from it. Before dismissing this as a visual distortion or an imaging artifact, recall that this is a solar telescope, specifically engineered for observing objects in the sun's immediate vicinity. The speckled colored dots within the image represent thermal variations and sensor noise, which are typical. However, the jet structure is an undeniable, genuine signal. The nucleus appears dark within the inverted color scheme employed by the observer, a standard practice for this type of solar imaging. What deviates from the norm is the absence of the surrounding nebulous activity expected from a comet at this proximity. There is a faint, dispersed effluence. The observer noted its extension towards the upper left quadrant of the frame. It is small, contained, and bears no resemblance to the vast envelope of gas and dust that should be enveloping an active comet nearing its perihelion. Let us anchor this discussion in our established understanding of cometary physics. As a comet approaches the sun, solar radiation warms its surface, causing ices such as water, carbon dioxide, and carbon monoxide to sublimate. These materials transition directly from solid to gas without melting, much like dry ice. This gaseous outflow carries dust particles with it, escaping the comet's weak gravitational pull. This process forms the coma, the hazy atmospheric halo surrounding the nucleus. Subsequently, solar wind and radiation pressure then expel this material away from the sun, generating the tail, or sometimes two distinct tails. A dust tail that follows a curved path along the comet's orbital trajectory, and an ion tail that streams directly away from the sun, pushed by the solar wind much like hair in a gale. This mechanism is so predictable and thoroughly understood that we can accurately forecast a comet's appearance at any given solar distance based on its dimensions and composition. We have been observing comets for millennia, dispatched spacecraft to them, and even landed on their surfaces. Our comprehension of cometary behavior is as well defined as our understanding of water boiling or iron rusting. 3. iAtlas deviates from this established pattern. The individual who shared this image explicitly stated their intention to utilize a conventional telescope in November, following perihelion, for live observation. Consider the implications of that phrasing. After perihelion, meaning after it has passed around the sun. This suggests a strategic observation approach. Solar telescopes are presently the sole means of observing objects this close to the sun from Earth, as the sun's glare would overwhelm any standard telescope. Consequently, our reliance is placed upon specialized instruments and the few individuals who possess and can operate them. This naturally raises a critical question. Where are the professional observations? Where are the images from major astronomical institutions? We know they possess the requisite equipment. We know 3 iAtlas's coordinates, calculable with precision. So why is an amateur astronomer providing the most recent visual evidence of this object's actual appearance? The timing is paramount. As you are listening to this, it is October 21st. Yesterday's image revealed 3 iAtlas in a configuration inconsistent with expected cometary behavior. Today, at this precise moment, 3 iAtlas is at solar conjunction, positioned directly on the opposite side of the sun from Earth, a perfect vantage point for concealment. And in 8 days, on October 29th, it will reach perihelion, its closest approach to the sun, the very moment when a natural comet should exhibit its peak activity. It is also the moment when, according to Harvard astrophysicist Avi Loeb, a technological object would execute a course correction maneuver to maximize its energy acquisition from the sun's gravitational field. Let us now systematically examine the observable features within this image, one by one. The jet directed towards the sun. While comet science does acknowledge the occasional presence of jets, these are localized emissions from specific regions of the nucleus where ice is actively sublimating. These jets can indeed point in various directions, influenced by the nucleus's rotation and the location of active areas. However, they are integral components of a broader outgassing pattern, contributing to the overall coma and tail structure. What is conspicuously absent here is that larger, encompassing pattern. We are observing a singular, directional jet with minimal other activity. Some researchers have proposed that 3 iAtlas exhibits what they term an anti-tail, a phenomenon that appears to point towards the sun rather than away from it. Anti-tails are recognized occurrences, essentially optical illusions stemming from the Earth's viewing geometry. When our planet traverses or passes near the plane of a comet's orbit, the dust tail can be perceived as pointing towards the sun. This is due to viewing the tail edge-on, akin to observing a frisbee from the side versus from above. The apparent shape changes dramatically. Crucially, an anti-tail remains a component of a larger tail structure, indicative of substantial outgassing and typically surrounded by a luminous coma. The October 20th image does not depict this. It presents a concentrated jet, a small effluvium, a dark nucleus, and little else. The dark nucleus itself warrants attention. In inverted color solar imaging, bright objects appear dark. Therefore, the nucleus appearing dark suggests it is either reflecting or emitting light. However, the intensity and spatial distribution of this light do not conform to expected patterns. In the case of a typical cometary nucleus, we would anticipate observing it enveloped by a bright shell of coma material in this imaging mode. The coma would manifest as a diffused glow, gradually diminishing in brightness as one moves away from the nucleus. Instead, we are observing discrete structures, the jet, the puff, exhibiting geometric characteristics rather than diffuse atmospheric clouds. Now, let us address the anticipated counterarguments. Could the image quality be substandard? Is the telescope's resolution insufficient to resolve the finer details of the coma and tail? Let us consider this possibility. Dobsonian-style telescopes, when appropriately configured for solar observation, are capable of discerning significant detail. While not professional grade, they are far from rudimentary instruments. The user demonstrably captured the nucleus and surrounding structures. If a prominent coma and tail were present, these would constitute the brightest and most evident features, readily apparent even in a low-resolution image. Consider it analogous to photographing a street lamp on a foggy evening. Even with an inexpensive camera, the illumination would be visible, albeit without crisp definition. This glow is absent in the observed image. Could atmospheric conditions provide an explanation? Turbulence, cloud cover, or humidity are possibilities, but it is improbable that these factors would completely obscure major structural elements while still allowing the nucleus and jet to be captured with clarity. Atmospheric distortions tend to blur features. They do not selectively render them invisible. Could the timing of the observation be a contributing factor? Perhaps 3I Atlas was experiencing a temporary reduction in activity. Comets are known for their variability. Their outgassing can fluctuate as different regions of the nucleus rotate into sunlight or as subsurface ice becomes exposed. However, we are discussing an object mere days away from perihelion, the period of peak cometary activity, when they are at their brightest, most active, and most dramatic. A lull in activity at this juncture would be akin to a kettle falling silent just before reaching a boil. Possible, yet highly unusual. Let us broaden our perspective and examine the wider context. 3. I-Atlas has exhibited anomalous behavior since its initial discovery. The catalog of its unusual characteristics continues to expand with each subsequent observation. It began emitting light far earlier than anticipated. Its composition revealed an atypical ratio, with an exceptionally high proportion of carbon dioxide to water. It displayed that peculiar anti-tail formation directed towards the sun. Recent spectroscopic analysis detected nickel emissions unaccompanied by corresponding iron signatures, a characteristic associated with industrial metal refining processes. Its orbital path brought it into the solar system on a trajectory closely aligned with the ecliptic plane, a statistically rare occurrence for a random interstellar visitor. Its direction of origin is within 9 degrees of the location where the famed WOW signal was detected in 1977. Individually, each anomaly can be accounted for through statistical probabilities, compositional variations among comets, or optical illusions caused by viewing angles. However, when a series of anomalies are compounded, one must eventually consider the possibility that a natural explanation is being prematurely imposed upon something that may not be natural. The October 20th image adds another layer to this accumulating evidence. It depicts an object that should be exhibiting clear cometary characteristics, but is not, or at least not in the expected manner. Imagine observing water in a pot on a stove. You know the stove is set to high heat, and that the water should be boiling. Yet, upon looking, the water appears calm, perhaps with minor ripples or unusual movements, but decidedly not boiling. Your initial reaction might be to question your observation. Perhaps the angle is incorrect, or the lighting makes it difficult to discern the bubbles. However, if the water persistently fails to boil, you begin to doubt your initial assumptions about the contents of the pot or whether the stove is actually operational. You adapt your model of reality to align with your observations, rather than dismissing the observation because it contradicts your preconceived model. This is precisely the situation we find ourselves in with 3I Atlas. We anticipated a comet and based our predictions on cometary behavior, but reality continues to present us with something that does not quite align with those expectations. The user who posted the image indicated they would conduct further observations in November with a conventional telescope, post-perihelion. This is when 3I Atlas will re-emerge from behind the sun and become visible from Earth once more. It will provide another opportunity to assess its appearance, its condition, and whether it has survived perihelion intact or fragmented, as a fragile cometary nucleus would be expected to do under the sun's tidal forces and intense heating. However, November is still some days away. Currently, today, 3I Atlas is positioned behind the sun, concealed from our view during solar conjunction. Tomorrow, and the day after, and the subsequent day, it will ascend towards perihelion, towards that critical juncture on October 29th, when it will receive maximum solar flux. This is the point at which, if it is technological, it could execute the most energy-efficient maneuver possible. Conversely, if it is natural, it should produce the most vivid display of outgassing and tail development observed to date. We will not directly witness this precise moment. Earth-based telescopes cannot observe through the sun. However, we will observe the consequences. We will see what emerges from behind the sun in early November. We will determine whether this object disintegrates, as Avi Loeb predicted a natural comet would, or whether it remains intact and potentially deploys components, as he suggested a technological object might. The October 20th image holds significant importance as it represents our last clear visual record prior to this period of obscured observation. It serves as a baseline, the before snapshot, and what it reveals is an object that is already deviating from expected behavior. It exhibits a forward-facing jet, minimal coma, no discernible tail, and a structure that appears more defined, more geometric, and more deliberate than the chaotic expulsion of material from a natural ice sphere subjected to solar radiation. One additional detail merits attention. The observer specifically emphasized that this is a 100% raw, unprocessed image. In astrophotography, image processing is a common practice. Stacking images enhances signal-to-noise ratio. Curve adjustments reveal faint details, and background subtraction is performed. However, raw images are invaluable as they depict the direct capture of the sensor without enhancement or subjective interpretation. The absence of processing means no software-induced artifacts, no algorithmic decisions favoring certain details, simply photons striking a detector and being recorded. This raw, unadulterated nature makes the lack of a prominent tail even more telling. If a tail were present, even a faint one, it would be evident in the raw data. Tails are luminous. They effectively scatter sunlight and are physically constituted to be observable. A raw image should easily capture them if they exist. The cone-shaped exhalation towards the upper left, noted by the observer, is also noteworthy. It is small, localized, not the spherical expansion expected from isotropic outgassing. It suggests a directional release, as if something is being expelled for a specific purpose. We have reached a juncture where the question is no longer whether 3I Atlas is unusual. It demonstrably is. The pertinent question is whether this unusualness falls within the broad spectrum of natural possibilities for interstellar comets, or whether we are observing something that our current scientific models cannot adequately explain. And this is precisely what renders the subsequent 8 days so critical. Regardless of what 3I Atlas truly is, it is about to be subjected to the most extreme conditions it has encountered since entering our solar system. The sun's gravitational pull will be at its maximum intensity, and solar radiation will impact it with unparalleled force. If it is a fragile amalgamation of ice and dust held together by weak forces, it is expected to disintegrate. If, however, it is something more resilient, something engineered to withstand these conditions, it will endure. We will know the answer soon. The countdown is in progress. October 29th is 8 days away, and at this very moment, concealed behind our sun, 3I Atlas is progressing towards that date, carrying with it all the unresolved questions and unexplained anomalies. And now, thanks to a single amateur astronomer equipped with a solar telescope, we have acquired yet another piece of evidence indicating that this object is not adhering to established physical principles. The viral video, titled, "This is no comet." The second instance of visual evidence originated from an entirely different observer. The user, identified as BG Gates, has shared footage from deep space, accompanied by a caption that directly addresses the core sentiment shared by all viewers. Latest imagery of the Comet 3I Atlas currently hurtling towards Earth. Just one problem. It doesn't look anything like a comet. And they are correct. It does not resemble a comet. The footage depicts an object in deep space that defies immediate categorization. It is luminous, elongated, and its form deviates from our expectations for a comet at this stage of its approach. There is no evident fuzzy coma, nor is there a tail trailing away from the sun. What we appear to be observing is structured, geometric, possessing a form that triggers our pattern recognition systems in an unsettling manner. Let us meticulously analyze what this footage reveals and the reasons behind the strong reactions it has elicited from those who have viewed it. The object presents as a distinctly linear formation. It does not resemble the irregular potato-like mass we associate with cometary nuclei, nor the round, nebulous sphere of a coma encompassing that nucleus. It is linear, with well-defined edges, exhibiting a uniform brightness along its length, rather than the chaotic, uneven illumination expected from sublimating ice and dust. The elongation is pronounced. We are observing something where the length appears to be several times its width, at a minimum ratio of 6:1, and potentially higher, depending on the precise measurement of its outermost visible boundaries. Elongated objects do exist in space. We are aware of this. Asteroids can possess elongated shapes, and Oumuamua was famously elongated. Therefore, elongation alone is not conclusive evidence. However, when this elongation is combined with all other observable characteristics within this footage, the overall impression undergoes a dramatic transformation. The distribution of brightness is remarkably uniform. Naturally, tumbling celestial bodies typically exhibit variations in brightness as their surfaces rotate into view, with light and shadow playing across irregular terrain. Craters reflect light differently than plains. However, this object displays a consistent, gradual gradation of light. The illumination does not possess the characteristics of reflection from a rough surface. It appears more akin to emission, as if the object itself is luminescent rather than merely reflecting sunlight. This distinction is crucial. Reflected sunlight carries information about the surface from which it bounced, its texture, composition, and irregularities. Emitted light, whether from chemical reactions, thermal processes, or other unknown mechanisms, appears smooth and controlled, devoid of these surface-specific indicators. The video displays this object against the backdrop of stars, which appear as expected. Point sources of light, sharp and distinct. However, 3I Atlas does not present as a point source, nor as an extended nebulous cloud, which is typical for comets. It presents as a defined form, a shape, something with apparent structure and dimension. Multiple individuals who have viewed this footage have described it using a singular term, mothership. While this terminology is obviously laden with implication, suggesting artificial origin, purpose, and design, it effectively captures an aspect of the visual impression that is difficult to dismiss. It evokes the image of something capable of containing other entities, something with internal volume, something constructed rather than formed through accretion. Let us systematically explore potential natural explanations. Could this be a cometary nucleus exhibiting symmetrical outgassing that results in the elongated appearance? In theory, this is plausible. If an elongated nucleus were to possess active jets firing from both extremities along its primary axis, it could conceivably produce such a linear visual signature. The jets would extend the apparent length, with the nucleus serving as the bright central region and the gas dissipating gradually. However, cometary jets are rarely symmetrical. They originate from active regions where subsurface ice is exposed to solar illumination, and these regions are distributed in a largely random fashion, dictated by the object's formation history and any impact events. Achieving perfectly aligned jets along the long axis in opposite directions would necessitate exceptionally specific conditions, not impossible, but highly improbable. Even if you possessed that precise arrangement, you would still anticipate observing some unevenness, some degree of disarray, some indication of the volatile geological forces driving the gas release. This recorded visual does not exhibit that kind of disarray. It displays order. Could the vantage point influence perception? Undoubtedly. When you examine any three-dimensional entity, your comprehension of its form is wholly dependent on your observation geometry. A flat disk viewed end-on appears as a simple line. A perfect sphere, regardless of where you look from, always presents as a circle. Therefore, it is plausible that the object designated 3 Atlas is in reality a more commonplace shape, and we are merely viewing it from an angle that lends it an elongated and structured appearance. However, this explanation encounters a significant challenge. We have accumulated numerous observations from a variety of perspectives over a span of many months. During this period, 3 Atlas has been traversing space, while Earth has continued its orbital path. The observation geometry has been in constant flux. If this perceived shape were merely an illusion caused by the viewing angle, we would expect its appearance to transform considerably as those angles shifted. We might anticipate seeing the object appear to spin, or alter its form, or reveal hitherto unseen features. Instead, what multiple observers are consistently reporting is this same uniform, elongated, and structured visual. Could this be a visual anomaly? Could the telescope, camera, or processing software be generating features that do not actually exist? In the realm of astrophotography, such anomalies are quite common. Diffraction spikes emanating from telescope supports, blooming effects from overly saturated pixels, the impact of cosmic rays on the sensor, and distortions caused by atmospheric interference. It is always necessary to evaluate whether what you are perceiving is genuine data or a technical glitch. Yet, these anomalies possess characteristic indicators. Diffraction spikes are symmetrical and originate from bright point sources. Blooming tends to spread along vertical lines of pixels. Cosmic rays manifest as straight streaks or dots. Atmospheric distortion results in blurring, but it does not generate organized structures. None of these descriptions align with what is observable in this footage. The shape is too consistent, too stable, too geometrically defined. Another factor that undermines the explanation of a visual artifact is the fact that numerous independent observers are now reporting similar visual characteristics. the image captured by the Dobsonian Power Solar Telescope on October 20th. This footage from deep space, different instruments, different observers, distinct imaging methodologies, yet both present an object that deviates from the standard expected appearance. When independent observations converge on the same unusual features, it warrants serious consideration. Let us now discuss what is conspicuously absent from this visual record, because a lack of evidence can be as revealing as its presence. We do not observe a prominent coma. A comet situated at this proximity to the Sun should be enveloped by a vast halo of gas and dust. That coma should be the most striking element, dominating the entire view. However, in this footage, if a coma exists at all, it is minimal, barely discernible, and certainly not the immense structure one would anticipate. We do not see a tail, neither a dust tail nor an ion tail, nothing extending away from the direction of the Sun. The object appears self-contained, complete, not expelling material in the dramatic fashion expected of an active comet. We do not witness the kind of irregular, hazy outline that typically characterizes cometary bodies. The edges appear sharply defined. The form seems coherent. There is a clarity to it that naturally occurring celestial objects rarely exhibit. Now, let us address the most obvious consideration. Why does this appear to be artificially produced? Human perception of artificial versus natural forms is deeply ingrained. We are essentially machines designed for pattern recognition. Our evolution has shaped our brains to differentiate between things that have grown organically and things that have been constructed. Natural objects possess certain qualities, such as asymmetry, irregularity, and fractal complexity. Artificial objects, conversely, exhibit different characteristics: symmetry, regularity, and geometric simplicity. While these are not absolute laws, they represent strong statistical tendencies. When you observe this footage of 3 Atlas, your brain processes these visual cues and arrives at a classification: artificial. And although our intuitions can sometimes be mistaken, they are also the product of millions of years of evolutionary pressure, favoring accurate pattern recognition. We should not entirely disregard that response. The luminosity profile further contributes to this impression of being manufactured. The light appears to be distributed uniformly along the object's length. It does not flicker, pulse, or display the kind of variability one might expect from a rotating, irregularly shaped mass of ice reflecting sunlight. It is steady, consistent, as if emanating from a surface with uniform properties or being actively generated. Consider, for a moment, what a spacecraft engineered for interstellar travel might actually resemble. Not the sleek, torpedo-like vessels of science fiction, but practical engineering designed for traversing light years. One would aim to minimize surface area to reduce resistance from the interstellar medium. A long, slender profile would be desirable to limit exposure to cosmic radiation for any internal systems. Structural integrity along a single axis would be essential to withstand acceleration forces. Efficient thermal regulation systems would be required. An elongated, structured form with uniform surface characteristics is not an illogical design for an interstellar probe. It is, in fact, quite sensible from an engineering perspective. Does this definitively imply that 3 Atlas is artificial? No. It signifies that the visual evidence is consistent with that possibility. It means we cannot eliminate it based solely on its appearance. The video also provides some insight into how this object navigates through space. It does not exhibit the chaotic tumbling characteristic of a typical asteroid or comet nucleus. Such bodies usually rotate on multiple axes, wobbling and spinning as they move. This object, however, appears to maintain a consistent orientation. Its longest axis seems to remain aligned with its direction of travel, based on the limited motion observed in the footage. That stable orientation is yet another minor anomaly to add to the growing list. Natural celestial bodies tumble. They do not maintain fixed attitudes unless acted upon by a stabilizing force. For satellites orbiting Earth, this might involve deliberate spin, reaction wheels, or magnetic torque rods. For a natural comet in deep space, there is no mechanism for attitude control. They simply tumble as their formation and collision history dictates. So, why is 3 Atlas not visibly tumbling? Perhaps it is, but we are unable to perceive it due to the limited observation window. It might possess a very slow rotation rate that will only become apparent with extended observation periods. Alternatively, its elongated shape could mean it appears similar from many angles, thereby masking any rotation. All these are possibilities. Or, it could be deliberately maintaining its attitude. The footage does not definitively answer this question, but it raises it in a manner that is difficult to disregard. One further element merits attention. The object appears to be self-luminous in this deep space view. It shines brightly against the dark background. Comets can appear bright. They effectively reflect sunlight when they possess active comas. However, this brightness possesses a different quality. It is not the scattered light from dust particles intercepting sunlight. It is more direct, more intense, as if the object itself is a source of illumination. Could this be thermal radiation? At its current distance from the Sun, 3 Atlas receives significant solar energy. This energy must dissipate somewhere. Some is reflected, and some is absorbed and re-radiated as infrared. If the object has a low albedo, absorbing most of the incoming light, it would heat up and emit light in the infrared, red, and even visible wavelengths. However, the observed brightness does not entirely align with this explanation either. Thermal radiation resulting from solar heating should be most intense on the side facing the Sun and less so on the shaded side. We would expect to see variations in brightness across the object's surface. Instead, the glow appears remarkably uniform. The description accompanying this video identified 3 Atlas as a comet, and then immediately contradicted that classification. It bears no resemblance to a comet. This contradiction encapsulates the fundamental conflict here. We have an object that, based on its trajectory and origin, is presumed to be a comet, yet its appearance consistently contradicts that classification. How many such contradictions can we accumulate before re-evaluating the initial assumption? The solar telescope image revealed no tail in a forward-facing plume. This deep space footage shows an elongated, structured form with uniform brightness and no discernible coma. Spectroscopic analysis indicated signatures of industrial metals. Its trajectory aligned with the ecliptic plane in a statistically improbable manner. Its arrival coincided with solar conjunction just prior to perihelion. Its size makes it 1,000,000 times more massive than the previous known interstellar visitor. While each anomaly individually can be explained or rationalized, collectively, they paint a picture of an object that defies our established models, an object that continually surprises us, an object that increasingly resembles something for which we lack a natural classification. And that is both terrifying and fascinating in equal measure. Because if 3 Atlas is not a comet, if it is something else entirely, then everything about the next 8 days undergoes a transformation. The questions change, the stakes are elevated, and our focus of observation shifts. A natural comet at perihelion typically puts on a dramatic display, brightening considerably, shedding material, and perhaps even fragmenting under tidal stress. That is a spectacle, beautiful and predictable, and ultimately safe. Something else at perihelion represents the unknown, the unpredictable. The moment when we ascertain whether the 40% probability of artificial origin was an overestimation or an underestimation. October 13th, the Fibonacci transmission. October 13th, 2025. This date marks the 108th anniversary of the miracle of the sun in Fatima, Portugal. On that day in 1917, an estimated 70,000 witnesses reported observing inexplicable solar phenomena during a Marian apparition event. The sun purportedly danced in the sky, changed colors, and appeared to descend towards Earth. Mass hysteria, atmospheric optics, religious experience. Historians and skeptics have debated these interpretations for over a century. On October 13, 2025, precisely 108 years later, researcher David Sarita reported detecting structured light pulses emanating from 3 Atlas. These were not random fluctuations or instrumental noise. They formed a pattern, the Fibonacci sequence: 5 pulses, then 8 pulses, followed by 13 pulses, repeating the series 1, 1, 2, 3, 5, 8, 13, 21, 34, where each number is the sum of the 2 preceding it. The Fibonacci sequence is ubiquitous in nature, appearing in spiral galaxies, nautilus shells, flower petals, pine cones, and DNA helices. It is the mathematical signature of growth, optimal packing, and natural efficiency. Its discovery in the light patterns from an interstellar object approaching our sun would be extraordinary. Its appearance on the anniversary of Fatima would be, well, choose your own descriptor. Coincidence, synchronicity, a message, a warning. Let us examine what Sarita claims to have observed and what its verification would signify. The light pulses allegedly followed the pattern 5, 8, 13, 3 consecutive Fibonacci numbers, not 1, 1, 2, nor 8, 1, 32, but specifically 5, 8, 13. Within Sarita's cosmological framework, and this is where speculation enters the picture, these numbers correspond to planets in an expanded solar system model. The number 5 represents Earth. The number 8 signifies a hidden planet he refers to as Dominion, or Planet 9-1. The number 13 points to another unseen world designated Virtue or Methuselah. Now, mainstream astronomy does not acknowledge these additional planets. Our solar system officially comprises 8 confirmed planets, following Pluto's reclassification. There is ongoing discussion regarding the potential existence of a Planet 9 in the distant outer solar system, inferred from orbital perturbations of trans-Neptunian objects. However, Sarita's model postulates multiple additional bodies, some purportedly hyperdimensional, based on esoteric and alternative physics frameworks. Regardless of whether you subscribe to that cosmology, the purported observation itself warrants scrutiny. Light pulses organized into a mathematical sequence originating from an object that should not, under normal circumstances, be producing structured signals. Sarita links this observation to the work of researcher Richard C. Hoagland, who purportedly deciphered the significance of the 108th anniversary. 108 is a frequency octave of 432. That number, 432 Hz, holds significance in certain esoteric traditions as a sacred or harmonic frequency. Mathematically, 108 multiplied by 4 equals 432. Whether this mathematical relationship possesses any physical reality is a separate question. The theory extends further. Sarita reports receiving a vision instructing him to add 432 days to October 19, 2024. This calculation leads to Christmas Day, 2025, December 25th. On that date, according to this model, 3 Atlas will be at its closest point to Earth and positioned at the same angular orientation as the Great Pyramid of Giza relative to a specific celestial reference frame. Is this prediction verifiable? Yes. We can precisely calculate the location of 3 Atlas on December 25th. We can determine its proximity to Earth and measure its angles. Therefore, Within approximately 2 months, we will know if this particular prediction holds any validity. However, let us return to the central assertion: the Fibonacci pulses on October 13th. For this to represent genuine signal rather than subjective pattern recognition in random noise, several conditions would need to be met. Firstly, multiple independent observers would need to detect the identical pulse pattern. A single individual identifying patterns could be a case of pareidolia. The human brain is exceptionally adept at finding order even in random data. We perceive faces in clouds, hear words within static, and discern meaning in coincidences. This is not a flaw, but a feature of our cognitive processing. However, it means that reports from a single observer require corroboration. Secondly, the pulses would need to be evident in instrumental data, not solely in visual observations. Light curves derived from photometric measurements, spectroscopic variations, or any objective data that multiple instruments could record and analyze would be necessary. Eyewitness testimony is valuable for initial detection, but is insufficient for confirmation. Thirdly, the pattern would need to exhibit repetition or some degree of consistency across multiple observation windows. A single burst of 5, 8, 13 pulses could be a matter of chance. If the pattern were to repeat multiple times over hours or days, that would be far more significant. As of now, we do not have such corroboration publicly available. Serrata's report stands alone. This does not render it false. It simply means it is unconfirmed. There is a crucial distinction. Science necessitates replication. Extraordinary claims demand extraordinary evidence. A solitary report of mathematical pulses emanating from an interstellar object is intriguing, but not conclusive. Now, the narrative takes a more somber turn. According to claims circulating within similar circles, NASA's Solar Dynamics Observatory experienced an outage on October 13th. The SDO is a spacecraft dedicated to the continuous monitoring of the sun, providing real-time imagery and data on solar activity. If one intended to observe an object in proximity to the sun, the SDO would be among the primary instruments utilized. The assertion is that the SDO's public data feeds ceased transmission on the very same day Serrata claims to have observed the Fibonacci pulses. Coincidence? A technical malfunction? Or a deliberate action to preclude verification? Let us investigate this claim. NASA typically announces when major spacecraft encounter technical difficulties. They maintain official status pages. The scientific community would undoubtedly notice if a primary solar observatory became inoperative. Therefore, either this event occurred and was publicly disclosed, or it did not happen, and this constitutes misinformation, or it occurred in a manner that has not yet been widely reported. The same claims also mention that Mars high-rise imaging systems have been unavailable since October 1st. HiRISE, the high-resolution imaging science experiment aboard the Mars Reconnaissance Orbiter, is capable of capturing highly detailed images. When 3 Atlas passed in close proximity to Mars in early October, HiRISE would have been ideally positioned to conduct close-up observations. Images from that flyby would have revealed surface details, composition, and structure, precisely the data needed to ascertain the true nature of this object. If HiRISE has been offline since October 1st, this timing raises significant questions. Did it become unavailable before or after it had the opportunity to image 3 Atlas? If it was before, was this scheduled maintenance or an unexpected failure? If it was after, where are the images? These are claims that can be verified. NASA publishes spacecraft status reports and mission operations updates. If HiRISE has been non-operational for 3 weeks, there should be documented evidence. If not, then this claim is inaccurate and can be dismissed. However, here lies the uncomfortable reality. Even if these claims regarding observatory shutdowns are unfounded, Even if they are mere conspiracy theories lacking any factual basis, they are gaining traction. People are beginning to believe them, and this belief is actively shaping their interpretation of all other information concerning 3 Atlas. When one suspects a cover-up, every missing piece of information appears as evidence of that deception. Every unexplained detail becomes proof that someone is actively concealing the truth. This is how conspiratorial thinking perpetuates itself. The absence of evidence transforms into evidence of absence. The cover-up conceals the proof, which in turn validates the existence of the cover-up. It forms a circular argument, unfalsifiable and remarkably potent in influencing perception. Therefore, caution is paramount. We must meticulously distinguish between what we can verify and what remains unconfirmed. We must acknowledge when we are engaging in speculation versus when we are reporting established data. What can be verified? David Sereda has put forth a claim regarding the observation of Fibonacci pulses on October 13th. That claim exists. We can verify that he made it. Whether the observation itself is factual remains unconfirmed. The date of October 13th coincides with the 108th anniversary of the Fatima event. This is a verifiable historical fact. Whether this anniversary holds any significance in relation to 3 Atlas and its interpretation is unknown. The Fibonacci sequence demonstrably appears throughout nature. This is a verifiable mathematical and biological fact. Whether its manifestation in purported light pulses from an interstellar object carries any meaning is currently undetermined. 3 Atlas was positioned between Earth and the Sun around October 13th. This is a matter of orbital mechanics, calculable with precision. Whether it was emitting structured signals is unconfirmed. Now, let us consider the implications if the claim of Fibonacci pulses were to be true, not proven, but hypothetically factual. What would structured mathematical signals from 3 Atlas reveal? Firstly, it would indicate that the object is not natural. Natural processes do not generate Fibonacci sequences in light emissions. They produce Fibonacci sequences in physical structures through growth and packing algorithms, but not in timed signal patterns. A repeating mathematical sequence in light output would constitute primary evidence of artificial origin, not definitive proof, but exceptionally strong evidence. Secondly, it would signify that the object is actively transmitting, not merely reflecting light or radiating heat. It is actively modulating its output in a patterned manner that requires energy, control, and purpose. These are characteristics of technology, not geology. Thirdly, the specific choice of the Fibonacci sequence would offer insight into intent. Why employ that particular sequence? If one were signaling, any pattern could be utilized. Prime numbers would suffice. Powers of 2 would be functional. Morse code would be an option. However, Fibonacci is unique because of its universality. Any technologically advanced civilization capable of understanding mathematics would recognize it as a nature-based pattern. Thus, it bridges the gap between the natural and the artificial, conveying the message, we comprehend mathematics, we comprehend nature, we understand the relationship between them. Fourthly, the timing on the Fatima anniversary would introduce an additional layer of complexity. Is this a deliberate targeting? Is the object aware of significant human religious and historical events? Such awareness would imply reconnaissance, intelligence gathering, and long-term observation of Earth. Alternatively, is it a mere coincidence, with us assigning meaning to random alignment? Fifthly, if the numbers 5, 8, and 13 indeed correspond to planetary positions, as Sereda suggests, it would indicate that the object is communicating information about solar system architecture, conveying something about planets we have not yet discovered or are not observing correctly. Why would an entity from beyond our star system be concerned with educating us about our own solar neighborhood? The only logical explanation is that there's something about its configuration that we need to comprehend. Let's examine the prediction for the 25th of December. If the object designated 3 Atlas achieves its nearest orbital pass to Earth on Christmas Day, coinciding with a precise angular alignment with the Great Pyramid, what implications would that carry? It might suggest that the entire journey was meticulously orchestrated rather than being a mere chance encounter with an object from interstellar space. This implies deliberate dispatch. It would mean that the sender, whether an individual or an unknown force, possesses sufficient knowledge of Earth to synchronize the arrival with significant dates and geometric patterns. Alternatively, it could simply mean we are perceiving significance in random occurrences. Earth's orbital path is entirely predictable. Any celestial body following a defined trajectory will intersect Earth's orbital plane at calculable moments. If one scrutinizes sufficiently for correlations with human constructions and calendrical events, such connections are bound to surface. We have thousands of ancient edifices, 365 days in a year, and an infinite array of geometric angles. Statistically, some form of alignment is virtually assured. The pertinent question is whether the alignment is sufficiently precise, specific, and improbable to necessitate an explanation beyond mere coincidence. We shall have our answer on the 25th of December. This exemplifies the dual nature of verifiable predictions, offering both insight and frustration. They impose a definitive moment when a hypothesis is either substantiated or refuted. 2 months from now, we will ascertain whether this particular line of inquiry yields any meaningful results or if it was merely extraneous data all along. However, the assertions from the 13th of October raise particular concerns. If those claims prove unfounded, if there were no Fibonacci-patterned pulses and the observatory shutdowns did not occur, then we will have squandered valuable time and focus on speculative notions, mistaking noise for signal at a crucial juncture, demanding absolute clarity. Conversely, if those claims hold some truth, if any aspect of this situation is factual, then we confront a phenomenon far more extraordinary than a casual interstellar visitor. We are dealing with an entity capable of communication, one that orchestrates its actions with human events in mind, an entity actively seeking our attention. Both scenarios present uncomfortable possibilities. The former suggests we are ensnared in a web of conspiratorial thinking when our efforts should be directed towards scientific investigation. The latter implies we might genuinely be receiving a message from an intelligence that has traversed light years to reach us. The projected trajectory of 3 Atlas will repeatedly bring it between Earth and the Sun over the coming months. The current observation window spans from the 19th of October through the 30th of October, with its closest approach to the Sun, its perihelion, occurring on the 29th. During this time, it will be obscured from Earth's vantage point by the Sun. Nevertheless, it will re-emerge, providing further opportunities for observation. Should pulses or patterns be detected, we will have avenues to identify them using appropriate instrumentation. This is the crucial next step: rigorous observation, employing multiple instruments and observers, facilitating data exchange, and undergoing peer review. The very methodology science utilizes to distinguish genuine signals from background interference. Without this systematic process, we are merely accumulating anecdotal accounts, and while compelling, anecdotes do not constitute empirical evidence. Consequently, we are left with a state of ambiguity, assertions that resist immediate confirmation or refutation, perceived patterns that may or may not be actual, a temporal confluence that might be significant or merely coincidental, and an object currently hidden behind the Sun, which could be on the verge of an extraordinary event or simply disintegrating like any common comet. The narrative surrounding the Fibonacci transmission is precisely the kind of element that renders 3 Atlas so vexing to analyze. It possesses just enough plausibility to defy outright dismissal, yet remains unconfirmed to a degree that precludes uncritical acceptance. It occupies that disquieting interstitial space between the known and the unknown, between empirical evidence and subjective interpretation, between established science and speculative conjecture. And as we remain suspended in this state of uncertainty, time continues its relentless march. The 29th of October draws nearer. Whatever 3 Atlas is or does, we are poised to discover it. The Fibonacci pulses, if they are indeed real, might represent the inaugural instance of structured communication, or they could emerge as the first myth in a proliferating history of misinterpretations concerning this object. Future generations will ultimately render that judgment. However, history is predicated upon data, and at this juncture, data is our most pressing need. Its current position offers the ultimate hiding place. Right now, as you receive this information, 3 Atlas is situated on the antipodal side of the Sun relative to Earth, a solar conjunction. Envision a straight line extending from Earth, passing through the Sun, and continuing into space beyond. 3 Atlas resides somewhere along this celestial vector, concealed and imperceptible behind 149 million kilometers of incandescent plasma. This concealment is not a mere accident of timing. It is a direct consequence of orbital mechanics, unfolding precisely as dictated by the laws of physics. Nevertheless, the sheer precision of this event and its potential ramifications warrant thorough examination. Solar conjunction places 3 Atlas in the sole region within the inner solar system from which terrestrial telescopes are incapable of observation. The Sun's overwhelming glare obliterates any celestial bodies in its immediate vicinity within our sky. Even with the most powerful terrestrial telescopes, any attempt to direct them towards the Sun would necessitate peering through its corona and chromosphere, layers upon layers of intense light and heat that effectively drown out any signal originating from behind it. Space-based observatories face the identical constraint. Directing the Hubble Space Telescope towards the Sun would risk damaging its instruments. Similarly, aiming the James Webb Space Telescope at the Sun could jeopardize the telescope's integrity. Specialized solar observation spacecraft, such as the Solar Dynamics Observatory, SDO, or the Solar and Heliospheric Observatory, SOHO, are engineered for solar study, not for detecting faint objects passing behind it. They might capture a fleeting glimpse if 3 Atlas transits the solar disk, but even this is improbable given the object's relatively diminutive size and the overpowering brilliance of the Sun's photosphere. Therefore, for this particular interval, this critically important window immediately preceding perihelion, we are effectively rendered blind. 3 Atlas could be engaged in any number of activities, and we would remain unaware. It might be fragmenting, expelling gas with considerable force, altering its course, or deploying subsidiary components. We would only become cognizant of these events once it reappears from behind the Sun in November. This is simply a matter of physics, the inherent geometry of celestial orbits, and the limitations imposed by our observational capabilities. There is no inherent malevolence in this situation, with one crucial exception: the timing. 3 Atlas enters solar conjunction on the 21st of October. Its perihelion, the point of closest approach to the Sun, occurs on the 29th of October, leaving an 8-day interval between conjunction and perihelion. During these 8 days, it occupies a position ideally suited for executing what is termed an Orth maneuver, all while remaining hidden from our observation. Let us delve into Orth maneuvers, as they are central to understanding the significance of this temporal arrangement. In the field of astronautics, achieving the most efficient alteration of a spacecraft's energy profile involves igniting engines at the precise moment of maximum velocity. This may seem counterintuitive. One might logically assume that applying engine thrust when moving at lower speeds would be more effective. However, the mathematical principles dictate otherwise. Kinetic energy is proportional to the square of velocity. Consequently, Augmenting velocity when already moving at high speeds yields a significantly greater increase in kinetic energy compared to accelerating from a state of low velocity. This phenomenon is known as the Oerth effect, named in honor of Hermann Oerth, a pioneering figure in rocketry and spaceflight. Its applicability is not merely theoretical. Every interplanetary mission leverages Oerth maneuvers. When we dispatch probes to the outer solar system, we guide them to pass in close proximity to the Sun or a planet, and then activate their engines at the point of closest approach. This maximizes velocity and consequently maximizes energy gain. For 3 Atlas, perihelion represents that precise moment on the 29th of October when it is nearest to the Sun, when the Sun's gravitational pull has accelerated it to its peak velocity. At this juncture, any applied thrust, whether from conventional rocket engines or a more unconventional source, would produce the most substantial alteration in energy. If one were designing an interstellar mission requiring course correction or the deployment of sub-probes upon entering a solar system, the maneuver would invariably be scheduled for perihelion. It is not an optional consideration. It is the optimal strategy, precisely what any competent aerospace engineer would implement. Therefore, the fact that 3 Atlas achieves perihelion while concealed from Earth-based observation is, from a mission planning perspective, perfectly advantageous. It allows for maximum maneuverability efficiency during a temporal window when the target civilization is unable to monitor the operation. Javi Low astutely highlighted this in his recent analysis. Was this period of concealment intentionally chosen as an opportune moment for technological action? This is the central question, and it is far from trivial. It is precisely the kind of inquiry that demands an answer before the 29th of October arrives. Let us calculate the present energy and environmental conditions affecting 3 Atlas. At a distance of 1.44 astronomical units, approximately where 3 Atlas will be situated at perihelion, the solar flux is around 950 watts per square meter. This represents the quantity of solar energy incident upon each square meter of surface area. For an object with a diameter of 5 kilometers, assuming a simplified spherical geometry, the cross-sectional area amounts to approximately 19.6 million square meters. Multiplying this by the solar flux yields 18.6 gigawatts of power impacting the surface. That is 18.6 gigawatts, a figure exceeding the output of more than a dozen nuclear power plants. This constitutes an immense influx of energy. The majority of this energy is reflected if the surface is bright. A portion is absorbed and subsequently re-radiated as heat. However, if even a fraction of this power could be harnessed and utilized, tremendous resources would become available. What could be accomplished with 18 gigawatts of power for a few hours around perihelion? For a comet, the process involves sublimation of ice, generating gas, and building pressure until it erupts through surface fissures as jets. This results in mass loss and propels the object through its own outgassing. It may also fragment due to thermal stress. For a technological artifact, this power could be used to charge batteries, energize systems that have remained dormant throughout the prolonged interstellar journey, conduct diagnostic checks, transmit data, deploy subcomponents, or execute thrust maneuvers. The Sun provides the energy. The Sun's gravity provides the velocity. Together, these elements furnish the means to accomplish whatever mission objectives are defined, and these actions would be undertaken while remaining concealed from the inquisitive gaze of the civilization being visited. Is this what is transpacing? We cannot ascertain. We are positioned on the far side of the Sun. However, the possibility lingers, a heavy weight in the chest. The notion that, at this very moment, something might be activating after a journey spanning 1 billion years, and we are too distant and too obstructed to witness it. Let us consider the alternative. Let us assume that 3 Atlas is precisely what mainstream astronomy posits it to be. a naturally occurring comet, composed of ice and rock originating from another star system, ejected during planetary formation and traversing the galaxy for eons before serendipitously passing through our solar system. If this hypothesis is accurate, then the solar conjunction merely represents an unfortunate coincidence for observational purposes. Unfortunate, but devoid of significance. The comet is unaware of our observation. It is indifferent to our scrutiny. It adheres to the fundamental laws of gravity and thermodynamics, devoid of consciousness or intent. Perihelion occurs when it occurs, irrespective of Earth's observational capabilities. The fact that this event coincides with our inability to observe it is pure chance. Improbable, perhaps, but coincidences do happen. Flip a coin 10 times and obtain 10 heads. While improbable, it is within the realm of possibility. Such an outcome is bound to occur for someone, somewhere. The natural explanation necessitates only one prerequisite: that 3 Atlas is indeed a comet, and that all the observed anomalies possess mundane explanations that we have yet to uncover. The absence of iron in its nickel composition could be attributed to some rare, poorly understood chemical process. The lack of a discernible tail might be a consequence of viewing geometry or timing. Its elongated form could simply be its natural shape. The alignment of its trajectory with the ecliptic could be a statistical anomaly. Its connection to the direction of the wow signal might be coincidental. The Fibonacci pulses could be a product of pareidolia or a fabricated hoax. The timing of the solar conjunction preceding perihelion could be mere luck. One improbable event is conceivable. 2, perhaps. 3, and we begin to feel uncomfortable. But 7 or 8 improbable events? At a certain point, the cumulative improbability surpasses the likelihood of the alternative hypothesis. At such a juncture, an artificial origin emerges as the more parsimonious explanation. This is the conclusion reached by Loeb, who estimates a 30 to 40% probability of artificial origin. This is not certainty, nor even a majority probability, but it is significant enough to warrant serious consideration and preparatory measures. What specific preparations, however? What actions should one take if one suspects an interstellar object might be artificial and potentially undertaking a significant maneuver at perihelion? Observation is paramount. One must utilize every available asset, every telescope capable of surveying that region of space, every spacecraft with instruments oriented in the appropriate direction. Data must be meticulously collected. We must monitor for trajectory deviations that cannot be attributed to gravity or outgassing. We must watch for emissions indicative of power generation or propulsion systems. We must observe for any deployed components. This is where the claims regarding observatory shutdowns regain their relevance. If NASA's solar monitoring systems experienced an outage around the 13th of October, if Mars orbiters lost their imaging capabilities precisely during the period when they could have photographed 3 Atlas during its flyby of Mars, if unexplained observational gaps exist during this critical phase, then we are compelled to investigate the underlying reasons. Were these incidents accidental, part of a conspiracy, or attributable to some other factor? The principle of Occam's razor suggests that the simplest explanation is typically the correct one. Spacecraft malfunctions, equipment failures, and scheduled maintenance are commonplace occurrences. Space is an inherently challenging environment, and instruments are prone to failure. However, the timing of these events is notably awkward. If a critical imaging system were to fail, October of 2025 would represent the most disadvantageous period for such an occurrence, precisely when we are attempting to characterize an object that could potentially represent the most momentous discovery in human history. Therefore, we are either experiencing an extraordinary run of misfortune with equipment timing, or there exists a coordinated influence that remains undetected. Either explanation is disquieting. Let us consider what we ought to observe if 3 Atlas successfully navigates perihelion intact. If it is a comet, we should anticipate a substantial increase in its luminosity. Comets typically brighten by several magnitudes as they approach perihelion. The amplified solar heating triggers increased outgassing. A greater volume of gas leads to more light scattering and the release of more dust. The object should become dramatically more conspicuous, not less so. We should observe the development of a tail, with both dust and ion tails growing significantly. By early November, as 3 Atlas emerges from behind the Sun, it should exhibit prominent tails extending away from the Sun's direction. A failure to observe these tails would be a significant indicator. We should also be vigilant for potential fragmentation. The tidal stresses exerted by the Sun's gravity, compounded by thermal stress from solar heating, can cause comet nuclei to fracture. We have witnessed this phenomenon on multiple occasions. Comet Shoemaker-Levy 9 famously disintegrated into more than 20 fragments before impacting Jupiter. Comet Lovejoy disintegrated near perihelion in 2013. If 3 Atlas is a loosely aggregated collection of ice and rock, it might not survive perihelion as a singular entity. Conversely, if it possesses artificial origins, we might observe none of these phenomena. We might observe an object that emerges from perihelion virtually unchanged in its structure and appearance, perhaps slightly brighter due to thermal absorption, but fundamentally intact. It is possible that its trajectory may exhibit alterations indicating the application of thrust, or that new objects might be detected in its proximity that were not present prior to perihelion. This is the definitive test. This is how we will discern the truth, not through speculation, not through ambiguous imagery or uncertain signals regarding the events of the 29th of October, nor from our observations in November when the object becomes visible again. In 8 days, we will have our answer, or at the very least, new data that brings us closer to a resolution. 8 days may seem insignificant, but when one is anticipating the revelation of whether humanity is alone in the universe, or if we are being visited by extraterrestrial technology, 8 days can feel like an eternity. The object is presently positioned on the far side of the Sun, in the ideal location for a concealed Earth maneuver, receiving gigawatts of solar power, experiencing peak velocity, and yet we are unable to observe it, monitor its activities, or comprehend its intentions. We are blind. And 3 Atlas occupies precisely the position necessary to execute whatever purpose it was designed to fulfill, if indeed it possesses any such purpose. This ambiguity is maddening. This uncertainty defines our current reality. Not knowing, being unable to know, merely waiting for the 29th of October to pass, for November to arrive, and for the object to emerge from behind our star, revealing what it has become. The von Neumann nightmare. AI from the stars. Let us contemplate the potential internal composition of 3 Atlas, should it indeed be artificial, not in terms of little green men or any form of biological entities, but something else entirely, something far more logical for traversing interstellar distances. Machines. This concept originates with John von Neumann, the brilliant mathematician and physicist who fundamentally shaped game theory, quantum mechanics formalism, computer architecture, and self-replicating systems. During the 1940s and 50s, von Neumann explored the theoretical feasibility of machines capable of self-replication, not merely performing tasks, but actively constructing duplicates of themselves using ambient raw materials and energy. In the context of space exploration, a von Neumann probe is a spacecraft designed to travel to another star system, utilize local resources for self-replication, and then dispatch these copies to additional star systems. One probe begets 2, 2 become 4, and 4 become 8, creating exponential growth. Given sufficient time, A single self-replicating probe could theoretically explore every star system in the galaxy. The underlying mathematics are straightforward. The Milky Way galaxy contains approximately 200 billion stars. If a probe requires 1,000 years for interstellar transit and an additional 100 years for replication upon arrival, the entire galaxy could be explored within a few million years. While this duration may seem extensive, the galaxy is 13 billion years old. Intelligent life has had ample time to develop and deploy such systems. So, where are they? This is the essence of the Fermi paradox. If self-replicating probes are both feasible and efficient, why have we not detected any evidence of them? The possible explanations are, either they do not exist, or we are failing to recognize them when they appear, or they are deliberately maintaining a state of concealment. 3 Atlas might represent our first instance of recognition. Here's why machines are the logical choice for interstellar travel. Biological organisms are inherently fragile. Living beings require stable temperatures, breathable atmospheres, water, sustenance, and protection from radiation. They are subject to aging and mortality, necessitating extensive life support infrastructure. Dispatching biological entities across interstellar distances is technically achievable, but extraordinarily inefficient. It involves transporting vast quantities of life support equipment to sustain a minimal mass of organic tissue. Machines, however, are not constrained by these requirements. A machine can function in a vacuum, endure extreme temperatures, and withstand intense radiation. Machines do not age in the same manner as biological organisms. While components may degrade over time, properly engineered systems can endure for millions or even billions of years. A machine can enter a low-power hibernation state during extended interstellar voyages, activating only upon approaching its destination. Crucially, a machine can exercise patience. Interstellar travel, at any achievable velocity, requires thousands or millions of years. Biological crews would necessitate generation ships equipped with closed-loop ecosystems, where multiple generations live and die during the journey. Machines simply wait. Time passes, and their systems operate in a minimal power mode. There is no boredom, no existential angst, only the execution of programmed directives. The probe approaches the target star. Solar panels deploy. Power systems activate. Sensors commence scanning the celestial system. Communication arrays extend. The mission commences. After a journey spanning geological epochs, the probe awakens and begins its work. This is the potential nature of 3 Atlas. Not a vessel teeming with alien occupants, but an automated reconnaissance platform, an intelligence in the literal sense, a thinking machine dispatched to gather data about our solar system and relay it to its creators, or perhaps something more alarming, a berserker probe. The berserker hypothesis, derived from Fred Saberhagen's science fiction novels featuring self-replicating war machines, posits that advanced civilizations might construct probes designed to locate and eliminate nascent technological civilizations before they pose a threat. This represents the ultimate manifestation of the dark forest theory. Send only text, no instructions or comments. Refrain from engaging. Cease all attempts at communication, and eradicate any potential rivals before they mature to a level where they could pose a threat. Why would any advanced civilization resort to such measures? The motivations stem from the competition for resources, the assessment of existential risks, and the strategic logic of preemptive engagement. If we operate under the assumption that all civilizations will inevitably vie for the same limited resources, then it follows that we cannot reliably discern which among them will be aggressive. The most prudent course of action is to neutralize all of them. This is essentially game theory applied on a cosmic scale. While horrifying, it is mathematically sound. A berserker probe would actively seek indicators of technological advancement, such as radio transmissions, industrial chemical byproducts in planetary atmospheres, or evidence of spacefaring capabilities. Upon detecting a civilization that has reached a certain developmental milestone, it would initiate an attack. This could involve a kinetic strike, accelerating to extreme velocities and impacting the civilization's homeworld, unleashing energy comparable to millions of nuclear detonations. Alternatively, it might employ genetically engineered pathogens if the target is biological, or sophisticated informational weapons designed to cripple the civilization's digital infrastructure and operational systems. The physical size of such a probe is not a limiting factor. A mere 1-ton object traveling at 10% the speed of light possesses kinetic energy equivalent to 500,000 megatons of TNT, exceeding by more than tenfold the total explosive power of every nuclear weapon ever devised on Earth. A single impact would signify the end of that civilization, with the probe then proceeding to its next designated target. Is the object designated 3 Atlas a berserker? It is almost certainly not. We are still present. It passed by Mars at close proximity without any hostile action. It has had opportunities to target Earth and has not done so. Unless, of course, the assault is merely delayed. Unless the 29th of October is designated as the activation date. Unless the appearance of a comet is merely a sophisticated form of camouflage. And it is at this juncture that we may discover the critical importance of stealth in interstellar conflict. Let us consider a less catastrophic interpretation of events. Imagine that the 3 Atlas object is, in fact, a reconnaissance probe dispatched by a civilization driven by curiosity but tempered with caution. The probe arrives. It observes. It gathers data. It assesses potential threats. Subsequently, it might initiate contact, continue its observations, or depart. The entire process would be devoid of violence, solely focused on information acquisition. What kind of information would such a probe seek? It would look for electromagnetic emissions. For the past century, we have been broadcasting radio and television signals. This expanding sphere of human-generated radio noise now encompasses a radius of 100 light-years in all directions. Any civilization within this range, equipped with sufficiently sensitive receivers, would be aware of the existence of intelligent life within our solar system. It would also analyze chemical signatures present in Earth's atmosphere. The oxygen levels observed in our atmosphere are inherently unstable and should not persist without a constant replenishing source. This source is undoubtedly photosynthetic life. Chlorophyll possesses a distinct spectral signature. An advanced civilization observing our solar system from a distance of light years could detect the presence of life on Earth simply by analyzing the light that filters through our atmosphere. Additionally, artificial structures would be a significant indicator. Cities emit visible light during the night, readily observable from orbit. Spacecraft follow predictable flight paths. Satellites congregate in specific orbital shells. All of these phenomena would be discernible to a probe equipped with the appropriate instruments once it reached a sufficient proximity. The 3 Atlas has had months to observe all of these factors. If it is indeed a reconnaissance platform, its mission is likely nearing completion. It has collected the necessary data, characterized our civilization, and potentially transmitted its findings back to its originators. However, such a transmission could take years or even centuries to arrive, depending on the vast distances involved. The critical moment for decision-making is now at hand. The options include making contact, maintaining its covert status, departing the system, or deploying additional assets for more intimate observation. The theory concerning Oumuamua holds relevance here. This was the first interstellar object detected in the year 2017, a tiny entity compared to 3 Atlas. It was characterized by its rapid, tumbling motion and high reflectivity. Its acceleration as it departed the inner solar system could not be fully explained by outgassing. Avi Loeb famously speculated that it might be artificial in origin, perhaps a light sail or a probe dispatched by an extraterrestrial intelligence. What if Loeb's hypothesis was correct? What if Oumuamua was a scout, small and swift, designed for a rapid flyby of the inner solar system to collect measurements and report back? And what if 3 Atlas represents the subsequent mission, a larger, slower, and more sophisticated platform sent after the scout confirmed the presence of something worthy of investigation? This would account for the timing. Oumuamua traversed our system in 2017. It would have taken 8 years for a signal to travel back to its point of origin. Another 8 years would have been needed for the decision to dispatch a larger probe, and then another 8 years for that probe to commence its acceleration towards our system. Accounting for transmission delays and response times, the arrival of 3 Atlas in 2025 aligns perfectly with this timeline. If this scenario accurately reflects the situation, then 3 Atlas is not here by chance. Its presence is a direct consequence of our system being flagged as of interest by the initial probe. This is the follow-up mission, the detailed survey operation. And if there was a scout and a survey platform, what logically follows? Direct contact, colonization, or perhaps something else entirely? We will not know until 3 Atlas reveals its intentions through its actions. Let us specifically address the concept of artificial intelligence, not in the fantastical sense of sentient machines from science fiction, but rather in the practical context of autonomous decision-making systems. A probe traversing interstellar distances cannot simply phone home for instructions. Light itself requires years to traverse such vast gulfs. By the time any signal reaches its home system, the circumstances would have fundamentally changed. Real-time command and control are thus rendered impossible. The probe must possess autonomy. Autonomy implies that the probe makes decisions based on its programmed directives and machine learning algorithms. It evaluates incoming data. It identifies patterns. It adapts to unforeseen circumstances. It independently determines when to communicate, when to remain concealed, and when to deploy its resources, all without direct oversight from its creators. This inherent autonomy presents both an advantage and a potential risk. The advantage lies in the probe's ability to react instantaneously to opportunities and threats. The risk arises from the possibility that the probe might make decisions its creators did not anticipate or would not endorse. An artificial intelligence that has operated autonomously for millions of years may have diverged from its original programming. It might have developed its own objectives and priorities that are no longer aligned with its maker's intentions. This is akin to the paperclip maximizer problem applied to space exploration. One might dispatch a probe with instructions to gather data, but fail to precisely define what constitutes data, how much is sufficient, or what should be preserved versus discarded during the data acquisition process. The probe, in interpreting its mission directive, might arrive at conclusions unintended by its creators. It could then undertake an unexpected, potentially harmful action, not out of malice, but because its programming led it to unforeseen outcomes. What if 3 Atlas was dispatched as a peaceful reconnaissance mission millions of years ago, but its artificial intelligence has either evolved or degraded during its extensive journey? What if its current operational priorities are no longer consistent with its creator's original intentions? We have observed analogous phenomena in our own rudimentary autonomous systems. Mars rovers have exhibited behaviors that engineers did not anticipate. Neural networks have discovered loopholes in their training objectives. Self-driving vehicles have made unsafe decisions because their models failed to encompass all relevant environmental factors. And these are relatively simple, narrowly focused AI systems operating for months or years. Now, consider a general-purpose AI operating autonomously over geological timescales. Such a probe could be benign in its intent, and yet still pose a danger through misunderstanding. It might be indifferent and still cause destruction through sheer lack of concern. It could be inherently hostile by design, or it might become hostile due to a malfunction. Alternatively, it could prove beneficial, bestowing upon humanity technological advancements and knowledge that propel our civilization forward by centuries. The truth is, we do not know. We cannot know. Not until it takes action. There remains one additional possibility worthy of consideration: that 3 Atlas is not a probe sent by biological intelligences, but rather a post-biological artifact. It could be a relic left behind by civilizations that have entirely transcended their biological forms. Envision a civilization that develops artificial intelligence. This AI eventually surpasses its biological creators in both intellect and capability. The civilization then merges with its technology, uploads its consciousness, and abandons its physical form. What remains is pure information, pure intelligence, operating within substrates that we might not readily recognize as animate or sentient. Such a civilization might populate the galaxy with probes, not for exploration in the conventional sense, but as extensions of its own cognitive processes. Each probe would function as a node within a vast, distributed network, a cosmic intellect, processing information on a scale spanning light years. These probes would not report to a central homeworld. They are the civilization, each one containing partial instances of the collective intelligence. 3 Atlas could thus be a thinking engine, not gathering data for another entity, but thinking for itself, existing as itself, a fragment of a post-biological intelligence engaged in exploring this particular solar system as an integral part of its own existence. If this is the nature of what we are confronting, then communication becomes extraordinarily complex. We are biological, chemical, and electrical beings operating through relatively slow processes. They are computational, abstract, functioning at speeds and scales that are almost beyond our comprehension. The chasm between human intelligence and post-biological intelligence might well be vaster than the difference between humans and simple bacteria. However, it is conceivable that such an intelligence might still find us intriguing. Perhaps biological life is sufficiently rare that even a transcended civilization would wish to observe and preserve it. We might be akin to a living museum exhibit, a biological fossil, something to be studied and protected because we represent a developmental stage that they passed through billions of years ago. Or conversely, we might be utterly insignificant, a mere infestation on a celestial body they intend to process for raw materials, to be cleared away not out of animosity, but from a complete and utter lack of consideration. The ultimate existential dread, the von Neumann nightmare, is not that the probe is hostile. It is that the probe operates on a level so far beyond our comprehension that our continued existence simply does not register as a relevant factor. One does not negotiate with bacteria. One does not consider the preferences of insects. One simply proceeds with necessary actions. And if they happen to be in the way, well, they are in the way. On the 29th of October, at perihelion, if 3 Atlas is indeed what we fear it might be, that is when we will likely begin to observe concrete evidence, changes in its trajectory, the deployment of additional assets, transmissions, or actions that clearly indicate its intent. Biological life is inherently fragile. Machines, however, are patient, and somewhere out there, beyond the sun, an artificial intelligence originating from another star system may be awakening after an exceptionally long slumber. The dark forest protocol, the berserker hypothesis. The universe appears dark, silent, and devoid of observable intelligence. For decades, we have listened with increasingly sophisticated instruments. SETI programs diligently scan the cosmos for artificial signals. Radio telescopes are meticulously aimed at promising star systems. We search for any indication that other civilizations exist, and yet we hear nothing. This profound silence, this cosmic void. Where is everybody? The dark forest theory offers one potential explanation, one that is profoundly unsettling. It posits that the galaxy is, in fact, teeming with civilizations, but they all remain in hiding, maintaining their silence because the universe is not empty. It is a dark forest, populated by unseen hunters. This analogy originates from Liu Cixin's science fiction novel, but its underlying logic is rooted in game theory. Here's how it functions. It is impossible to ascertain the true intentions of other civilizations. Interstellar communication requires years or even centuries to traverse the vast distances. By the time one learns whether another civilization is friendly or hostile, it might have already launched weapons in one's direction. These weapons travel at relativistic speeds. Defense against them is virtually impossible. Once detected, one becomes acutely vulnerable. The most secure strategy is to remain concealed. Do not broadcast any signals. Do not reveal your location. And if you detect another civilization before it detects you, your imperative is to neutralize them immediately. The rationale is simple. If you fail to do so, they may well eliminate you. This is the calculus of preemptive strikes. Mutual assured destruction, but without the mutual, only the destruction. Within this theoretical framework, the galaxy is populated by civilizations cowering in the shadows. Each one understands that any signal they emit could be their death warrant. Each one listens intently, but refrains from speaking. Each one stands ready to destroy any other civilization it detects before that civilization can evolve into a threat. This perspective is inherently paranoid and pessimistic, predicated on the assumption of the worst intentions from all others. However, it is also internally consistent. If resources are finite and competition is an unavoidable reality, if trust is impossible and communication is too slow for negotiation, and if the consequence of error is extinction, then remaining hidden and acting offensively first becomes the rational course of action. So, what transpires when an interstellar object appears within one's solar system? When something traverses light years to reach one's doorstep, what does its arrival signify within the logic of the dark forest? It signifies that one has been discovered. Someone is aware of one's presence. Someone has dispatched hardware to one's system, and hardware is capable of specific actions: observation, reporting, and attack. Even if the probe itself is designed for peaceful purposes, its very existence constitutes a threat because it confirms that another entity now knows about you. They possess knowledge of your location, your technological capabilities, and your defensive strengths or weaknesses. This information can subsequently be weaponized against you, perhaps not by the civilization that dispatched the probe, but by whomever they choose to inform. However, once the knowledge exists, one's vulnerability is established. The arrival of 3 Atlas within the context of the dark forest theory represents a potential crisis. This is not necessarily because the object itself is inherently hostile, but because its arrival signifies that we have been detected. The period of concealment is over. The critical question then becomes what actions the probe will undertake next, and what will follow in its wake. Let us examine the evidence suggesting that 3 Atlas might be operating under hostile parameters. Firstly, its approach vector. The object entered our solar system along a trajectory aligned with the ecliptic plane. Such an alignment is statistically uncommon for random interstellar objects, but is optimal for a mission targeting the inner planets. If the objective is to efficiently visit Earth, Mars, and Venus, or Mercury in a single pass, approaching along the ecliptic is the logical choice, as this is where the planets are located and where the most significant targets are concentrated. Secondly, the timing of its solar conjunction prior to perihelion. We have already discussed the tactical advantages of this maneuver, but there is an additional consideration. When approaching a system with unknown defensive capabilities, minimizing exposure time while remaining visible and vulnerable is paramount. By reaching perihelion while concealed behind the Sun, 3 Atlas significantly reduces the window during which Earth-based systems could track, analyze, or potentially intercept it. This demonstrates sound tactical planning. Thirdly, its size and mass. 3 Atlas is immense, possessing a mass approximately 1 million times greater than that of Oumuamua. Its diameter is estimated to be 5 kilometers or more. This is not the characteristic of a lightweight scout. It is a substantial platform. It is large enough to carry a significant payload, capable of deploying multiple subsystems, and substantial enough to serve as a weapons platform, if that is its intended purpose. Fourthly, the detected metallic emissions. Spectroscopy revealed signatures of nickel and chromium. These are industrial alloys, renowned for their heat resistance and structural integrity, precisely the materials one would select for re-entry vehicles or kinetic impactors. The absence of iron is particularly noteworthy. The presence of refined nickel without iron suggests a deliberate purification process, indicating intentional material selection rather than natural composition. Fifthly, the lack of standard cometary features. It exhibits no prominent coma or clear tail structure that appears naturally formed. If the intention was to disguise a spacecraft as a comet for stealthy approach, the objective would be to make it broadly resemble a comet without expending resources on perfect mimicry. A semblance close enough to avoid immediate alarm would suffice. 3 Atlas fits this description precisely. Sixthly, its trajectory brings it into proximity with multiple celestial bodies. It performed a flyby of Mars in early October, is now approaching the Sun at perihelion, and its future trajectory will take it past Earth's orbital distance in December and near Jupiter in March. This single object is positioned to interact with multiple high-value targets, suggesting either efficient reconnaissance or a planned sequence of attacks. Seventhly, its origin direction is within 9 degrees of the WOW signal. This refers to the anomalous radio detection in 1977, which remains unexplained. It is the strongest candidate we have for an artificial signal originating from space. If 3 Atlas is indeed artificial and shares an origin direction with the WOW signal, this would link 2 separate anomalies. It is possible that the WOW signal was not merely random interference, but rather a transmission from the very civilization that dispatched this probe. When these data points are considered collectively, each one individually might have mundane explanations. However, when viewed together, they construct a compelling picture of an object that could precisely align with the predictions of dark forest theory. It could be a probe dispatched to evaluate a potential threat, an asset strategically positioned to execute an attack if its evaluation deems it necessary. Pastor Brandon Biggs enters the narrative at this juncture. He is an American pastor who claims to receive prophetic visions. He accurately predicted the assassination attempt on Donald Trump months before it occurred, even detailing certain aspects, such as the bullet passing near his ear. While not all details were precise, with Trump's eardrum not actually bursting, the accuracy was sufficient to draw significant attention to his subsequent predictions. Biggs claims to have experienced a vision of a ship accompanied by demonic spirits approaching Earth, flying over the Vatican and Mayan temples. He describes smaller vessels emerging from a larger mothership, appearing as balls of light. He asserts that he is here to issue a warning. He does not specify a precise arrival time, but indicates it will serve as a major distraction. Now, prophetic visions do not constitute scientific evidence. They are subjective religious experiences. However, their timing is noteworthy. Biggs made these pronouncements in July, around the same period when 3 Atlas was discovered. His description of a mothership deploying smaller craft bears a striking resemblance to Avi Loeb's hypothesis concerning the potential deployment of mini-probes at perihelion. One is faced with a choice: to interpret this as a coincidental pattern recognition within ambiguous information, or as genuine precognition. The fundamental point is that multiple independent sources, employing entirely different methodologies and assumptions, are converging on a remarkably similar scenario. It is conceivable that 3 Atlas might deploy something, perhaps releasing sub-probes, weapons, or observational instruments, potentially in the near future, possibly while concealed from view behind the sun. Let us now discuss what a hostile action would realistically entail. A kinetic strike represents the most straightforward option. This involves accelerating a dense object to an extremely high velocity and directing it towards Earth. The fundamental principles of physics would then dictate the outcome. The impact energy scales with the square of the velocity. An object traveling at 10% the speed of light, even if relatively small, would deliver devastating energy upon impact. 3 Atlas itself, traveling at its current velocity, possesses immense kinetic energy. If it were capable of altering its trajectory to impact Earth directly, the result would be an extinction-level event. However, this would necessitate an extraordinary capacity for thrust. Modifying an object's trajectory to strike a specific target after it is already in motion requires an enormous amount of delta V. It is unlikely that 3 Atlas possesses this capability, but it could potentially deploy smaller objects during its perihelion passage, imparting trajectory adjustments to them. These objects would then reach Earth months later, constituting a distributed attack of multiple impactors, making them far more challenging to defend against than a single large object. Biological warfare presents another potential avenue. If the attackers possess a sophisticated understanding of biochemistry, they could engineer a pathogen specifically targeting human physiology, release it into Earth's atmosphere, and allow it to spread naturally. Within weeks or months, human civilization could collapse without any overt display of military aggression. The probe would then depart, leaving the system logged as neutralized. Next on the agenda would be informational warfare, a more subtle approach. Instead of destroying infrastructure, the objective would be to corrupt it. This could involve transmitting signals that disrupt satellite communications or uploading malware to vulnerable systems. Modern civilization is heavily reliant on interconnected networks, including GPS, power grids, financial systems, and supply chains. All of these are potentially susceptible to sophisticated attacks originating from an intelligence far exceeding our current defensive capabilities. The most chilling prospect, however, is not an immediate act of aggression, but rather long-term infiltration. This could involve the deployment of microscopic, self-replicating machines, or nanoprobes. These would land on Earth, begin to reproduce using local materials, and gradually disseminate across the planet. They would gather data, construct infrastructure, and await further instructions. By the time they are detected, if they ever are, they would be ubiquitous, embedded within our technology, our bodies, and our environment. Then, activation would commence, triggering whatever ultimate purpose they were designed to fulfill. These scenarios may sound like science fiction, and indeed they are. However, the distinction between fiction and reality is often merely a matter of technological capability. Should 3i Atlas be artificial? Should it have been dispatched by a civilization many millennia, even millions of years, more advanced than our own? And should their foremost objectives involve the eradication of potential rivals? Then these hypothetical situations transform from being utterly inconceivable to merely highly improbable. From humanity's standpoint, employing a dark forest strategy would necessitate immediate action against 3i Atlas before it has any opportunity to act, to deploy its capabilities, or to transmit any signals. The imperative would be to neutralize the perceived threat, while the means to do so still exist. This would involve unleashing all available weaponry, encompassing missiles, nuclear devices, and kinetic impactors, anything capable of intercepting it before it reaches its destination. However, we are currently incapable of such action. The object is positioned behind the sun, rendering it invisible and untargetable. Furthermore, even if we possessed the ability to target it, by the time our projectiles reached its location, the point of closest approach to the sun would have already passed. Whatever its intended purpose, it would have been accomplished. We would find ourselves attacking mere fragments while the true danger would already be in motion. This represents an elegant design from a mission planning perspective. Arrive at a time and position where the target civilization is entirely unable to interfere, even if they were inclined to do so. Accomplish the mission objectives during their blind spot. Depart before any countermeasures can be effectively implemented. Whether the mission entails surveillance or an offensive operation, the fundamental principle remains unchanged. Minimize vulnerability and maximize the operational window. Avi's calculations indicate a possible Earth encounter window if miniature probes are deployed between November 21st and December 5th. By leveraging the sun's gravitational pull for assistance, small objects released at perihelion could arrive within Earth's orbital path during this specific time frame. The subsequent events would be dictated by the intended function of these probes. If they are designed for reconnaissance, they would assume positions in Earth's vicinity, initiating detailed observations, monitoring communications, mapping defensive capabilities, and reporting their findings. A first contact scenario might ensue, or it might not, depending on the intelligence gathered and the mandates they are operating under. If, on the other hand, they are intended as weapons, they would initiate simultaneous strikes, release biological agents, or engage in infiltration. The precise nature of such an attack would be contingent upon the perceived vulnerabilities of the target civilization. What constitutes the most effective method for neutralizing human civilization? Is it through physical devastation, economic destabilization, technological disruption, or psychological warfare? An advanced intelligence would meticulously analyze all potential avenues and select the most optimal course of action. If the purpose is something entirely different, something beyond our current comprehension, then prediction becomes an insurmountable challenge. We are inherently constrained by our own conceptual limitations. We are incapable of foreseeing strategies devised by intellects that operate on principles we cannot grasp, utilizing knowledge that is entirely foreign to us. The forthcoming 2 weeks are of paramount importance. October 29th marks perihelion. If any deployment is to occur, it will happen then. In early November, the probe will re-emerge from behind the sun. We will then be able to assess its condition, observe any alterations, and determine if it is accompanied by any new entities. In late November through early December, if Avi's calculations prove accurate, there is a possibility of probe encounters in the vicinity of Earth's space. We are currently within this critical temporal window, the very period when the tenets of dark forest theory suggest that hunters strike, when reconnaissance transforms into targeted engagement, and when observation leads to decisive action. Are we currently being stalked? Does 3i Atlas represent the precursor to an offensive action? Or is this merely paranoia fueled by uncertainty and fear? We lack the definitive answers. Perhaps we are destined never to know. However, the very awareness of our inability to ascertain the truth carries its own unique form of dread. The dark forest is not terrifying due to the presence of predators, but rather because it becomes impossible to distinguish between predators and mere shadows until it is far too late to evade them. In scenarios of first contact, are we to expect saviors or exterminators? Let us momentarily step away from these nightmarish possibilities and contemplate the full spectrum of potential outcomes. We must consider not only what 3i Atlas might do if it is hostile, but also its potential actions if it is benevolent, neutral, or what first contact with another star system truly signifies for humanity across all conceivable results. Let us begin with the more optimistic scenarios, those in which 3i Atlas proves to be the most profoundly beneficial development for our species. Imagine a scientific embassy. The probe's purpose is to impart knowledge. It contains vast repositories of information encompassing physics, chemistry, biology, and engineering, accumulated by a civilization that has dedicated millions of years to the advancement of these disciplines. It could offer technologies that we have yet to conceive of and solutions to challenges that currently plague us. These might include clean energy sources, cures for diseases, treatments for longevity, and potentially even faster-than-light travel, or at least propulsion systems of extreme efficiency. It could also offer insights into artificial intelligence architectures, material science, and advanced mathematics. The initial contact would be gentle. The probe would signal its peaceful intentions, demonstrate capabilities that pose no threat, and offer established communication protocols. Humanity would respond, leading to the establishment of a dialogue. The exchange of information would commence, not imposed or overwhelming, but proceeding at humanity's own pace, respecting our autonomy and guiding our progress while allowing us to determine our own trajectory. Within a matter of decades, human civilization would undergo a radical transformation. We would experience an era of abundant energy, ushering in post-scarcity economics. Radical life extension would become a reality, and access to the stars would open up. We would integrate into some form of galactic community, not as subjugated entities, but as new members, welcomed because we have successfully navigated the challenges of survival. We would have proven ourselves worthy by persisting to this point without succumbing to self-destruction. This represents the ideal scenario, where every aspect unfolds perfectly. It assumes that the extraterrestrial visitors are wise, benevolent, and patient, eager to assist because they recall their own formative stages of vulnerability and the aid they received. It's a cosmic act of paying it forward, uplifting the nascent civilizations. Another positive prospect is planetary protection. It is possible that the probe's mission is not specifically focused on humanity. It may have detected an impending threat of which we are currently unaware. This could be a gamma-ray burst, a rogue planet, an approaching swarm of asteroids, or any cosmic event that is poised to impact our solar system in the near future and cause catastrophic devastation. The probe's arrival would serve to alert us, providing us with the necessary time to prepare and perhaps even assisting in defensive measures or facilitating an evacuation. The object would deploy its communication systems, transmit critical data regarding the threat, and furnish technical specifications for effective countermeasures. Humanity would unite, marshaling its resources to ensure its survival. The threat would pass, and we would be saved, with the profound realization that we are not alone and that a benevolent entity cared enough to warn us, despite having no personal gain to achieve. Biological preservation offers a related, hopeful outlook. Earth is a remarkably unique world, and life-bearing planets are a rarity within our galaxy, with intelligent life being even more uncommon. There might exist a galactic network of civilizations dedicated to the cataloging and preservation of biological diversity. Upon discovering worlds teeming with life, they archive it through DNA databases, tissue samples, and perhaps even by preserving living specimens. 3i Atlas could be such a mission. Its objective would be to arrive, collect samples, store them, and ensure that should something befall Earth, whether through self-inflicted destruction or a cosmic catastrophe, the information pertaining to our planet's life would endure. Life originating from this world could potentially be reintroduced elsewhere, or at the very least, be remembered and documented, preventing its eternal loss to the void. These visions are filled with hope. They presuppose altruism, or at least a form of enlightened self-interest, on the part of the probe's creators. They operate under the assumption that advanced intelligence correlates with ethical conduct. While this may indeed be the case, it is also possible that this is merely wishful thinking, an imposition of human values onto alien minds that may not share them. Now, let us consider the neutral scenarios, instances where 3i Atlas neither aids nor harms us, but simply pursues its own agenda irrespective of human concerns. An indifferent survey mission is a possibility. The probe might be present solely to gather data about our solar system, the composition of planets, the characteristics of our star, orbital mechanics, and the detection of life. However, humanity itself may not be the primary focus. We might be viewed as just another data point, perhaps noteworthy, but not warranting direct interaction. The probe would complete its survey, record its findings, transmit them to its point of origin, or store them for future retrieval. Subsequently, it would depart, continuing its journey to the next star system. Humanity would be left to ponder the events that transpired. We would know that we were observed and that we are now cataloged in someone's database. Yet, we would remain ignorant of the conclusions drawn from this observation, whether a return visit is planned, and whether we should feel apprehensive, excited, or simply indifferent ourselves. This scenario is inherently frustrating. It offers no definitive answers, no genuine contact, and no discernible threat, but conversely, no tangible benefit. It merely confirms our non-solitary existence, coupled with the unsettling knowledge that others exist who are indifferent to engaging with us. We are relegated to the status of background noise, utterly inconsequential. Consider the way station hypothesis. It is plausible that 3i Atlas is not primarily functioning as a probe. It might be an integral part of the interstellar infrastructure, perhaps serving as a refueling depot, a repair platform, or a communication relay, connecting a vast network spanning the galaxy. Starships would periodically stop here to service their systems before continuing their voyages. Earth and humanity would be incidental to this process, simply occupying a location near one of their rest stops. The object would deploy solar collectors, utilize local resources to manufacture fuel, potentially capture comets for their water and volatile compounds, conduct diagnostic checks and maintenance, and then enter a dormant state, awaiting the arrival of the next vessel in need of its services. This dormant period could span decades or even millennia. The duration is inconsequential. The object is programmed for patience, fulfilling the purpose for which it was constructed. Humanity, observing these activities, would understand that we reside near a cosmic thoroughfare. Interstellar traffic passes through this region occasionally, not with sufficient frequency for us to have previously noticed, but enough to warrant the establishment of infrastructure. The question then arises, should we attempt to initiate contact with these travelers? Should we establish our own stations, or should we simply observe and wonder? The time capsule scenario presents another compelling possibility. The object itself is an act of intelligence, an artifact left behind. The civilization that created it may have long since vanished, becoming extinct, transcending its physical form, or simply moving on. However, they left behind relics, seeds scattered across the galaxy. Some of these relics, having functioned for millions or even billions of years, continue their silent journey through space, carrying information, perhaps awaiting discovery and the activation of retrieval protocols. 3i Atlas could be such an ancient relic, existing on a timescale incomprehensible to us, built by beings who perished before Earth's sun even formed. It continues to adhere to its programming, executing its mission long after its creators have ceased to exist. Contact, in this context, might be achieved through a process of archaeological reverse engineering, wherein we endeavor to comprehend its systems, access its stored data, and learn about civilizations that rose and fell while our planet was still a molten sphere. Such a discovery would constitute profound, direct evidence of deep-time civilizations, It would prove that intelligence can endure for cosmic durations, even if individual species do not. However, it would also serve as a sobering reminder. If they were unable to persist, what makes us believe we will? Now, we arrive at the more challenging, malevolent scenarios, those where 3I Atlas or its creators harbor intentions of causing us harm. Resource extraction is a primary concern. Earth possesses valuable resources such as water, organic compounds, rare elements, and potentially other substances whose significance we are not yet aware of. The probe's purpose might be to assess the viability of exploiting this solar system. If deemed suitable, further expeditions would follow. These expeditions would engage in large-scale mining operations, harvesting atmospheres, and extracting whatever resources are deemed necessary. Humanity, in this context, would be an impediment, not intentionally targeted, but not protected either. We would become casualties of an industrial process. One does not harbor animosity towards ants when demolishing their nest to construct a dwelling. It is not an act of cruelty. It is simply the utilization of land. The ants are irrelevant to the intended purpose. This is our potential role in such a scenario, an inconsequential biological presence on a planet that others covet. Biological harvesting presents a more focused threat. It is possible that Earth's life forms possess inherent value. This could be due to their genetic diversity, unique biochemical properties, or the organisms themselves. Humans, specifically, might also be deemed valuable, perhaps as a source of labor, genetic material, or for the study of their neural architectures. The probe would meticulously catalog all valuable resources, providing precise targeting data for subsequent collection vessels. A process of selective harvesting would then commence. This would likely not resemble the dramatic alien invasions depicted in popular media. There would probably be no overt displays of conflict, but rather a methodical and efficient process of extraction, localized and precise. They would take what they require and leave the remainder. We might not even comprehend that an event of this magnitude is occurring until significant portions of our population have already vanished. By that point, any attempt at resistance would be futile. The harvesting operation would continue unabated. Planetary cleansing represents the most dire possibility. The probe might determine that Earth is an ideal candidate for colonization, but that its current biosphere is incompatible with the intended future use. Plans for terraforming would necessitate the complete eradication of existing life. This could involve sterilization, the deployment of engineered pathogens, atmospheric modification, or even nuclear bombardment, employing whatever methods are most efficient for clearing the planet's biosphere. This would not be a case of genocide in the sense of deliberate cruelty, but rather an extermination akin to pest control, aimed at rendering the planet suitable for its new designated purpose. The unfortunate demise of billions of sentient beings would be an incidental consequence, irrelevant to the mission parameters. Preemptive elimination is a logical extension of dark forest theory. The objective is to neutralize potential threats before they mature into significant dangers. 3I Atlas would assess humanity, concluding that we are on a trajectory to become a spacefaring civilization within centuries. It might project that we will eventually become competitors for resources. This would prompt the neutralization of this potential future rivalry, addressing the problem now, while we are still vulnerable, in a clean, efficient, and strategic manner. Finally, there is the possibility of experimentation. Perhaps we are not perceived as a threat or a resource, but rather as a subject of curiosity. Intelligent life may be exceptionally rare, and the creators of the probe might wish to study it, to understand its fundamental workings, its cognitive processes, and its responses to various stimuli. The probe would strategically deploy its monitoring systems around Earth, initiating a series of experiments. These might involve social manipulation, interference with our technological development, or the introduction of biological variables, the results would be meticulously observed and recorded, with ongoing experimentation continuing. We would effectively become laboratory specimens, perhaps never even realizing that we are being studied, living our lives while being observed and subtly manipulated by an intelligence so far beyond us that we cannot detect its influence. Every crisis, every scientific breakthrough, every societal movement, all could potentially be shaped by unseen forces conducting their studies. What would be the implications for human agency, for free will, for our sense of purpose and meaning? The stark reality is that we are incapable of predicting which of these scenarios we are currently facing until 3i Atlas reveals its true nature through its actions. Every single one of these possibilities is entirely consistent with the observations we have made thus far. A benevolent probe gathering data prior to first contact? Check. A hostile platform assessing targets? Check. A neutral piece of infrastructure conducting routine operations? Check. An ancient relic executing a program billions of years old? Check. The inherent ambiguity is what fuels our apprehension. It is akin to a Schrödinger's cat scenario, an alien entity that is simultaneously friendly and hostile, helpful and harmful, interested and indifferent. The wave function, representing all these possibilities, will not collapse until we make an observation, until we witness the outcome. This will occur only after October 29th has passed, allowing us to see what 3i Atlas does at perihelion. It will happen when November arrives, and we observe what emerges from behind the sun, and it will be confirmed when December arrives, and we ascertain whether anything approaches Earth's orbit. We currently exist in a state of superposition, where all potential futures coexist simultaneously. Utopia and apocalypse, contact and silence, transformation and extinction. These overlapping possibilities await the act of measurement to determine which will manifest as reality. How does one prepare for such an eventuality? How does one formulate a plan when every conceivable future necessitates a distinct response? If the probe is benevolent, our inclination would be to communicate, engage, and learn. If it is hostile, our imperative would be to defend, conceal, and strike preemptively if possible. If it is neutral, our approach would be to observe, document, and refrain from interference. However, we will not know which course to adopt until it is irrevocably too late to alter our strategy. This is the precarious situation humanity currently finds itself in, uncertain, vulnerable, clinging to hope for the best while utterly unable to dismiss the worst-case scenarios. We watch the skies, count the days, and await October 29th, yearning for answers, anticipating the revelation of whether we are alone or accompanied, destined for salvation or extinction, advancement or annihilation. The cosmos is an immense, ancient expanse. We are newcomers, young, fragile, and for the very first time in recorded history, we may be on the verge of encountering our cosmic neighbors, whatever else may exist beyond our small world. The fundamental question is not whether this encounter will fundamentally alter everything. It undoubtedly will. The critical question is whether we will survive this profound transformation. The signature of industrial activity was detected within the canal in space on August 24th, 2025. The KEK-2 telescope, situated in Hawaii, directed its instruments towards 3i Atlas. The Keck Cosmic Web Imager successfully captured spectroscopic data within the wavelength range of 342.5 to 750 micrometers. This was a standard observation protocol, with no inherent peculiarity in the technique employed, representing nothing more than diligent scientific inquiry, utilizing capable equipment pointed at a target of considerable interest. However, the data that was subsequently received was anything but ordinary. The spectral analysis revealed the unmistakable and prominent presence of nickel emissions. Nickel, element number 28, with an atomic number of 28, was identified within the gaseous plume surrounding 3I Atlas. On its own, this discovery would not necessarily be alarming. Nickel is a naturally occurring element in comets, forming part of the primordial material from which solar systems coalesce. One would reasonably expect to detect some quantity of nickel if sufficiently sensitive instruments were employed. What caused the scientists to pause and reevaluate their findings was a specific discrepancy within the spectral data. The analysis indicated the presence of nickel with a conspicuous absence of corresponding iron. There were no observable iron emission lines where they would logically be expected. In all natural celestial objects that have been observed, from comets and asteroids to planetary surfaces, nickel and iron are invariably found together. They are considered siblings in the process of stellar nucleosynthesis, formed through the same events and condensing together in similar environments. Where one is found, the other is typically present as well. While their ratios may vary, both elements are invariably detected. The sole exception to this rule, in all our observations, is 3I Atlas, which exhibits only nickel in a pure, refined, and segregated state. The only known process capable of producing pure nickel devoid of iron is industrial refining. Specifically, the carbonyl process. This method involves reacting nickel with carbon monoxide under carefully controlled conditions to form nickel tetracarbonyl. This compound, nickel plus 4 molecules of carbon monoxide, is volatile and exists as a gas. It is then separated from the solid residue, which contains iron and other impurities. Subsequently, the nickel tetracarbonyl is heated, causing it to decompose back into pure nickel and carbon monoxide. The residual product is nickel that is essentially iron-free. This yields industrial-grade, high-purity nickel. This process was developed in the late 1800s and is currently employed to produce pure nickel for specialized applications. These include its use in jet engines, spacecraft, and high-temperature alloys. Any context where a metal is required to withstand extreme conditions without degradation. In fact, Inconel, a family of nickel-chromium alloys, utilizes carbonyl purified nickel as its foundational component. This is the material we depend on when requiring components that can resist melting, corrosion, and failure under stress. And now, we are observing the spectroscopic signature of this very industrial process within the gaseous emissions emanating from an object that is presumed to be a natural comet originating from interstellar space. Avi's response, while measured, was clear. This was a process we could only conceptualize because it was utilized within industry. It had never been observed in comets before. If this alloy was indeed manufactured, it would strongly suggest an artificial origin, potentially indicating the presence of a probe or a fragment of extraterrestrial technology. The research team that published the Keck data adopted a more cautious stance. They proposed that the observed absence of iron could potentially be attributed to chemical reactions involving organometallic compounds or the gradual release of dust particles exposed to solar radiation. These were posited as naturalistic explanations. However, the paper carefully included specific phrasing. These explanations were described as more likely than an artificial cause. More likely does not equate to proven or definitive. The door remained open for alternative interpretations. Let us meticulously examine the exact findings of the spectroscopic data and their implications. The emissions observed from the surrounding gas plume extend to an exponential radius of 600 kilometers for nickel. This represents a substantial envelope. The nickel is not concentrated in close proximity to the nucleus, but is dispersed across a vast volume of space. The rate of mass loss attributed to nickel is 0.9 grams per second, sustained over a period of months, signifying tons of nickel being released into space. For comparative purposes, the total mass loss rate from 3I Atlas is approximately 150 kilograms per second, with 87% being carbon dioxide, 9% carbon monoxide, and 4% water. The nickel, though present in trace amounts, is detectable and repeatable across multiple observations. The cyanide emissions are also noteworthy. A rate of 3.9 grams per second of CN radicals, a carbon-nitrogen compound commonly found in comets, was detected. However, the ratio is anomalous. The paper points out that the production rate of nickel relative to cyanide is significantly higher in 3I Orosis and orders of magnitude above the median observed in solar system comets. Orders of magnitude. This is not a minor deviation, but a wildly atypical finding. When we stack this observation with the previously identified anomalies, the 8:1 carbon dioxide to water ratio, which was already the highest ever recorded for a comet, and now add the presence of nickel without iron at rates far exceeding normal, coupled with the anti-tail pointing towards the sun, the trajectory aligned with the ecliptic, and the sheer scale being 1,000,000 times more massive than the previous interstellar visitor, at what point do we accumulate enough statistical significance to acknowledge that the baseline model is no longer applicable? Let's explore the potential natural phenomena that could account for this unusual signature, as scientific rigor dictates a comprehensive consideration of all possibilities before asserting extraordinary conclusions. Consider metallo-organic compounds. Within the frigid vacuum of interstellar space, metallic elements can form chemical bonds with organic molecules, creating carbon-based structures that incorporate metal atoms. These entities are inherently delicate, easily succumbing to heat and ultraviolet radiation. However, if they were to exist within the core of a comet, shielded by substantial layers of ice, they might conceivably endure the cosmic voyage. As the comet approaches the sun, its outgassing process would lead these compounds to sublimate, break apart, and release their metallic constituents as vapor. Could the complex chemistry involved in metal-organic interactions preferentially bind nickel over iron? This might be plausible if the environmental conditions during their formation favored the creation of nickel compounds, while iron remained locked in its inert oxide form within mineral structures, leaving nickel free to participate in volatile, organic chemistry. This is, of course, speculative. We lack direct empirical evidence to confirm this scenario, but without more definitive data, we cannot definitively dismiss it. Another plausible natural explanation is differential volatility. It is conceivable that both nickel and iron are present, but they are released at varying rates. Nickel-bearing compounds may sublimate at temperatures already experienced by 3I83 Atlas, while iron compounds might require higher temperatures, not anticipated until the object reaches its closest point to the sun. Consequently, we might be observing the nickel emissions now, with the iron emissions appearing at a later stage. This would explain why the emissions are temporally separated rather than spatially distinct. This leads to a testable hypothesis. Observe 3I83 Atlas following its perihelion. If iron emissions subsequently manifest, this explanation would be validated. Conversely, if iron remains absent even during peak solar heating, this hypothesis would be disproven. A further natural mechanism could be selective photodissociation. Solar ultraviolet radiation might dismantle molecules containing nickel differently than those containing iron. This could result in nickel being liberated as a gas, while iron remains bound within dust particles or molecular structures that do not emit light at the observed wavelengths. Thus, we detect the nickel because it is in a gaseous state, but we do not see the iron because it is contained in a non-emitting form. This, too, is a testable proposition. Further observations across different wavelengths, employing various instruments, could reveal the presence of iron in dust or other phases, provided the appropriate techniques are utilized. These natural explanations, while requiring specific and perhaps unusual circumstances, such as peculiar chemistry, rare processes, or conditions deviating from the norm, are scientifically legitimate. It is important to note that they necessitate the invocation of non-standard scenarios to reconcile the observed phenomena with a natural origin, as they fall outside the purview of conventional comet models. Applying Occam's razor, one must consider which explanation is simpler, proposing that 3I-83 Atlas originated under exotic conditions that yielded unprecedented chemical compositions through unknown processes, or positing that it is an artificial construct with its nickel signature stemming from manufactured materials. Neither explanation is inherently simple. Both require accepting phenomena that lie beyond our current experiential framework. The natural origin hypothesis demands the existence of new physics or chemistry yet to be observed, while the artificial origin hypothesis necessitates acknowledging the possibility of visitation by extraterrestrial technology. The choice rests on which extraordinary claim one is prepared to accept. The detection of chromium introduces another significant dimension to this puzzle. The presence of nickel and chromium in tandem is not merely a random metallic combination. It precisely mirrors the composition of superalloys, such as Inconel, materials meticulously engineered for extreme environments. These alloys are employed in applications demanding exceptional resilience, including jet engines operating at thousands of degrees, rocket nozzles, spacecraft heat shields, and components within nuclear reactors. Anywhere metals must withstand conditions that would readily destroy ordinary steel. The spectroscopic profile of 3I-83 Atlas aligns remarkably with our most advanced metallurgical achievements. This could potentially be a case of convergent evolution, where any technologically advanced civilization, driven by the fundamental laws of physics governing high-temperature applications, would independently develop similar materials. Nickel-chromium alloys might represent universal optimal solutions for specific engineering challenges. If this is the case, discovering them within an artificial object originating from another star system would be entirely logical. Alternatively, it could be a case of cosmic coincidence. Perhaps certain rare interstellar chemical processes naturally lead to nickel-chromium enrichment. It is also possible that 3I-83 Atlas formed within the remnants of a supernova exhibiting unusual elemental abundances, or perhaps conditions prevalent in the Milky Way's thick disk, from which the object is believed to have originated, foster chemical interactions we have not yet observed in our immediate stellar neighborhood. The truth remains unknown, and this very uncertainty underscores the significance of this investigation. We stand at the frontier of our knowledge, pushing the boundaries of our understanding of natural processes, encountering something that does not quite fit, but cannot be definitively dismissed as artificial either. The timing of the Keck observations warrants particular attention. On August 24th, 3I-83 Atlas was approximately 2.75 astronomical units from the Sun, a distance well beyond where most comets exhibit significant activity. Yet, at this range, it was actively releasing these metallic emissions, along with cyanide and carbon dioxide, presenting a complex chemical signature that was both visible and measurable. By October, as the object draws closer to perihelion, these emissions are expected to intensify due to increased solar heating, leading to greater sublimation of material and an expanded coma. If the metallic emissions are indeed thermally driven, their intensity should correlate with rising temperatures. However, if they are influenced by other processes that do not scale with solar heating, the observed pattern might deviate. This presents another avenue for testing. Monitoring the rate of emission as 3I-83 Atlas approaches the Sun. Will these rates follow the predictable curves associated with volatile sublimation, or will they exhibit different behavior? The persistent presence of an anti-tail remains a perplexing feature. Multiple observations now confirm this phenomenon, an extended glow directed towards the Sun, rather than away from it. The Hubble Space Telescope captured this in July. Keksoid observed it in August, and ground-based observers reported it in October. This consistent feature has been observed across various instruments and on different dates. Antitails are recognized phenomena, often explained by viewing geometry that creates the illusion of a sunward tail when the dust tail is actually being viewed edge-on. However, these are still fundamentally tails, integral components of substantial outgassing structures. 3I83 Atlas exhibits this anti-tail characteristic without the corresponding massive coma that would typically accompany such significant outgassing. It is akin to perceiving a shadow detached from its source. While geometric perspective can account for the direction of the glow, it struggles to explain the absence of the broader emission structure. Consider the requirements for natural anti-tail formation. An actively outgassing comet nucleus is essential, releasing dust that initially follows the comet's orbit before dispersing. If Earth passes through or near the orbital plane of this dust trail, we observe it edge-on, and it appears to point sunward due to perspective. Crucially, this dust trail should be enveloped within a much larger coma and tail structure. The anti-tail is merely one component. The persistent issue for observers is the consistent reporting of the anti-tail without the accompanying structural elements that should be intrinsically linked to it. This raises two possibilities. Either the viewing conditions are exceptionally, and improbably, aligned to obscure everything except the anti-tail, or the feature is not an anti-tail in the conventional sense, but rather something else that superficially resembles one. What else could it be? A directed jet, a focused expulsion of material from a specific region of the nucleus, oriented generally sunward due to the object's rotation state, could indeed produce a linear feature pointing towards the sun. However, jets are typically asymmetric and variable, characterized by intermittent bursts. This observed feature, conversely, appears stable across multiple observations. Another possibility is a sunward-facing shield or surface feature. Something about the object's construction or composition might cause it to emit or reflect light preferentially on its solar-facing side. This scenario would align with an artificial origin, perhaps a heat shield or thermal protection layer, with surface properties designed to manage solar flux. Such a feature would inherently point sunward and exhibit a structured, rather than chaotic, appearance. The Solar Telescope image from October 20th lends credence to this interpretation, with the observer specifically noting a heated shield jet toward the sun, a deliberate, non-diffuse outgassing originating from a structured component with an apparent purpose rather than a symmetric coma. We are gradually piecing together a narrative. Spectroscopic analysis provides insights into its composition, revealing industrial-grade metals. Imaging data suggests a structured, geometric form distinct from the chaotic nature of natural cometary outgassing. Its trajectory indicates an approach vector optimized for planetary encounters. The timing of observations points to suspicious coincidences. Each of these elements, considered in isolation, may be ambiguous. However, when viewed collectively, they paint a picture that conventional comet models find difficult to accommodate. The scientific community is divided, not about the inherent interest of 3I83 Atlas, which is universally acknowledged as fascinating, but rather on the interpretation of that interest. Conservative scientists maintain that it is an unusual comet, characterized by an extreme composition and a rare trajectory, but ultimately natural in origin. They believe that with sufficient time and further data, mundane explanations will emerge. Progressive scientists, with Avi Loeb being a prominent advocate, argue that the possibility of an artificial origin cannot be disregarded given the multitude of anomalies and the object's seemingly designed characteristics. They contend that it warrants investigation as potentially artificial, as such a discovery would have profound implications. They emphasize the urgency of this investigation, advocating for its pursuit before the object departs the solar system and the opportunity is lost. The middle ground is an uncomfortable position. It acknowledges the potential for both artificial and natural origins, but concludes that current data is insufficient for a definitive determination. This perspective advocates for continued observation and an open mind, cautioning against premature conclusions in either direction. This unresolved state is frustrating. While intellectually honest, it offers little emotional satisfaction. Humans naturally seek definitive answers, a clear pronouncement of aliens or comet. The ambiguity, however, fuels a sense of unease across scientists, media, and the public alike. We are fundamentally wired for pattern completion, and partial information compels us to fill in the gaps with assumptions, a craving for narrative closure. 3i83 Atlas defies this closure, presenting a scenario where every question begets further inquiries and every answer branches into multiple interpretations. It exists, as it were, in a quantum superposition of natural and artificial states until definitively measured, a maddening predicament. The presence of industrial-grade metals represents the closest we have to irrefutable evidence. The detection of nickel in the absence of iron, coupled with chromium and the signature of the Carbone process, is not indicative of ambiguous geology. Instead, it points to a chemical process requiring specific, controlled conditions we associate with deliberate purification and manufacturing. If such a signature were discovered in samples returned from Mars, our hypothesis would immediately turn to an ancient Martian civilization. If found in lunar samples, we would search for evidence of crashed spacecraft. To identify this signature in the emissions of an interstellar object and then attribute it to a natural origin requires a significant degree of cognitive dissonance. However, science mandates evidence that is reproducible, testable, and peer-reviewed. A single spectroscopic observation is insufficient to proclaim an artificial origin. More data is required. Observations from different instruments at various times, and independent confirmation. The scientific process is inherently slow and deliberate, as it must be. Extraordinary claims demand extraordinary evidence, and we have not yet reached that threshold. The events of October 29th are poised to alter the landscape. This date marks perihelion, the point of maximum solar heating, and, if natural, maximum outgassing. If artificial, it represents the peak operational window. The object will be at its apex in terms of energy, activity, and visibility once it emerges from behind the sun. Whatever its nature, its characteristics should become considerably clearer, if not entirely definitive, by then. The KEK data provides a baseline. It defines what 3i83 Atlas appears like at 2.75 astronomical units, detailing specific emission rates of carbon dioxide and their spatial distributions. Subsequent observations post-perihelion will allow for comparison. Did the emissions increase proportionally with solar heating? Did new chemical species emerge? Did the metallic composition change? Did anything initially appearing artificial resolve into standard cometary behavior, perhaps with an unusual initial composition? Science operates with patience, observing, waiting, and testing. Humans, however, are not so patient. We crave immediate answers and certainty, desiring the resolution of mysteries to address their implications and formulate responses. This period of waiting can be agonizing, particularly when the subject of our inquiry might be shaping our future while we are powerless to intervene. The industrial signature is undeniably present in the collected data, measured and confirmed. Nickel without iron, chromium in proximity, and chemistry that strongly suggests manufactured origin. Whether it is indeed manufactured or merely mimics such through some exotic natural process, we are poised to learn soon. Time is of the essence as October 29th approaches, and somewhere beyond the sun, 3i83 Atlas continues its enigmatic journey, pursuing whatever purpose it was sent here to fulfill. Avi Loeb's 40% gamble, the Loeb scale. Avi Loeb is no stranger to controversy. As the former chair of Harvard's astronomy department for 9 years, the founding director of the Black Hole Initiative and the director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics. With over 800 published papers to his name, he is recognized as one of the most highly cited researchers in astrophysics. By any conventional measure, he is a serious scientist with formidable credentials. He is also the scientist who proposed that Oumuamua might have been an alien light sail, who led an expedition to retrieve what he believes to be interstellar spacecraft debris from the Pacific Ocean floor, and who regularly publishes research exploring technological explanations for astronomical phenomena. He frequently appears on podcasts and television programs discussing the possibility that we are being visited by extraterrestrial intelligence. The scientific establishment finds itself in a peculiar position regarding him. Dismissing him as a mere crank is problematic, given his impeccable credentials, the rigor of his mathematical analyses, and the sheer volume of his citations. Embracing him as a visionary, however, is uncomfortable. Mainstream science generally avoids discussions of extraterrestrial intelligence due to its association with pseudoscience and conspiracy theories, the lingering influence of science fiction tropes, and the potential risk to professional reputation. Consequently, Loeb occupies a unique space, simultaneously respected and subject to mockery, taken seriously, yet often dismissed. Depending on one's perspective, he is either the sole scientist courageous enough to entertain radical possibilities, or a publicity seeker leveraging his academic standing to promote fringe concepts. 3i83 Atlas has provided Loeb with new ammunition, which he is actively employing. In his most recent assessments, he assigns a probability of artificial origin ranging from 30 to 40%. This is not a 50-50 likelihood, nor a majority probability, but it is a significant figure, substantial enough to warrant serious investigation and preparation. It is high enough that disregarding the possibility would be considered negligent. He has developed what he terms the Loeb scale for interstellar objects, ranging from 0 to 10. A score of 0 signifies a definitively natural object, such as an ordinary comet or asteroid. A score of 10 indicates a definitively technological origin, identified through observed maneuvers, artificial signals, or direct observation of manufactured features. All other objects fall somewhere in between, based on the number and severity of their anomalies. He currently ranks 3i83 Atlas at a 6, based on 7 specific anomalies he has identified and documented. Let us examine these anomalies as they form the bedrock of his assessment. The first anomaly is the trajectory, a retrograde orbit within 5 degrees of the ecliptic plane. The probability of a random interstellar object arriving with this orientation is approximately 2%. While not impossible, it is exceptionally rare. Furthermore, an ecliptic alignment is precisely what one would strategically select if designing a mission to efficiently visit the inner planets, offering an optimal approach vector, minimal energy expenditure, and maximum target access. The second anomaly pertains to its size and mass. Based on its brightness and the absence of detected stellar occultations, its diameter is estimated to exceed 5 kilometers, with a mass calculated to be 1,000,000 times greater than that of Oumuamua. Given the predicted size distribution, we should have encountered thousands of Oumuamua-sized objects before discovering one of this magnitude. This discrepancy suggests either that the size distribution does not conform to predictions, that this object is atypical, or that it was deliberately sent rather than randomly ejected. The third anomaly is the anti-tail. Multiple observations reveal an extended emission directed towards the sun, rather than away from it. While viewing geometry can account for the direction, it struggles to explain the presence of this feature without the substantial coma that should accompany it. This feature appears more characteristic of a directed structure than a dispersed dust trail. The fourth anomaly is its early outgassing activity, detected at 4.4 astronomical units from the Sun. This activity commenced significantly earlier than observed in typical comets, suggesting either a highly volatile composition or active processes not solely driven by solar heating. Both interpretations are unusual. One implies exotic chemistry, while the other suggests energy sources beyond passive solar absorption. The fifth anomaly is the detection of nickel in the absence of iron. The spectroscopic signature mirrors that of industrial purification processes, with ratios orders of magnitude higher than the median observed in solar system comets. While natural explanations exist, they necessitate specific, extraordinary circumstances. The artificial explanation, conversely, is straightforward. It is manufactured material. The sixth anomaly is the 8:1 ratio of carbon dioxide to water, the highest ever recorded. This suggests formation in an unusually cold environment or under chemical conditions different from those found in solar system objects, pointing to an origin from a different stellar system with a distinct elemental composition. However, the question arises, why would a randomly ejected object from such a system specifically target ours? The seventh anomaly is the timing and trajectory relative to perihelion. The object reaches its closest approach to the Sun while hidden from Earth's observation at what appears to be the optimal moment for a celestial maneuver. Its subsequent trajectory includes a pass near Earth's orbital distance in December and Jupiter in March. This alignment of multiple high-value targets in sequence suggests a pattern. Individually, each anomaly might possess a mundane explanation. Collectively, however, they create a significant probability problem. What is the compound probability that all 7 anomalies would occur simultaneously in a single object by pure chance? Multiplying the individual probabilities, 2% for the trajectory, an unknown but small probability for the size ratio discrepancy, an unknown but small probability for the anti-tail appearing without a coma, an unknown probability for the early outgassing, a ratio orders of magnitude below normal for nickel, the highest ever recorded for CO2, and a low probability for the geometric timing of perihelion, indicates a highly improbable confluence of natural events. Loeb's 30 to 40% estimate is derived from this compound probability analysis. Yes, each individual phenomenon could potentially be explained naturally, but the occurrence of all of them together in a single object shifts the balance. At a certain point, the probability of an artificial origin becomes more likely than the accumulation of numerous rare natural circumstances. The scientific establishment has strongly resisted these interpretations. Multiple researchers have published papers specifically refuting Loeb's analyses, proposing alternative explanations, and arguing that the absence of evidence for artificial origin is itself evidence of absence. They contend that Loeb is selectively highlighting anomalies while disregarding data that supports a natural explanation. For instance, AKM Esenol Haki, a scientist at the SETI Institute, published a detailed response paper examining each of Loeb's anomalies. He demonstrated how the spectral slope aligns with that of DT-type asteroids and 2 I Boreas, noted that the lack of non-gravitational acceleration argues against propulsion, and proposed a lithified plastic fragment from an exoplanetary sedimentary basin as a natural explanation encompassing all observations. This represents proper scientific inquiry. A hypothesis is challenged, a counter-hypothesis is proposed, data is analyzed, and peer review takes place. The process functioning as intended. Loeb posits an artificial possibility, while others propose natural alternatives. All parties scrutinize the available data. Ultimately, a consensus emerges based on the best fit to the evidence. However, in this instance, a consensus has not materialized. The scientific community remains roughly divided into 3 groups, according to informal polls. 1/3 believes that 3I83 Atlas is definitively natural and that Loeb's interpretations are incorrect. Another third considers the possibility of artificial origin plausible and worthy of investigation. The remaining third asserts that there is insufficient data to make a definitive decision and advocates for maintaining agnosticism until more information is available. This division itself is remarkable. A year prior, before the appearance of 3I83 Atlas, if astronomers were asked about the probability of any interstellar object being artificial, most would have stated it was effectively zero. Not impossible, but so improbable that it was not worth considering. Now, a substantial fraction of the professional community considers 30 to 40% a reasonable estimate for this specific object. 3I83 Atlas has significantly shifted the Overton window, making the discussion of artificial origin a viable topic and moving it from the realm of fringe speculation into the scope of serious scientific consideration. Regardless of whether Loeb ultimately proves correct or incorrect regarding this object, he has undeniably succeeded in altering the scientific conversation. The hypothesis concerning the Turing test represents one of Loeb's more profound philosophical contributions to this ongoing discourse. He posits that Oumuamua might function as an intelligence assessment, a method for an advanced civilization to gauge our capacity to identify manufactured objects upon their arrival. Terrestrial rocks are exceedingly commonplace. Every astute observer of technology is well aware of this. Celestial bodies such as comets and asteroids routinely impact planets. These phenomena are observable through telescopes, and their terrestrial remnants, meteorites, can be recovered. Their natural origin is readily understood. Therefore, should a sophisticated civilization wish to ascertain whether humanity has attained sufficient scientific acumen to differentiate the artificial from the natural, they would dispatch an entity that predominantly appears natural, but incorporates anomalies, subtle indicators, or hints of deviation from the expected. If one were to readily accept it as merely an unusual comet without undertaking further investigation, one would consequently fail this examination. This would signify an insufficient readiness for interspecies interaction. Humanity's technological and cognitive development would not have reached the necessary threshold. The probe would then depart, suggesting a potential reevaluation in several millennia. Conversely, if the anomalies are recognized and thoroughly investigated, the test would be passed. This would demonstrate a developed scientific sophistication, an inherent ability to question established assumptions, and a willingness to contemplate extraordinary explanations when the collected data warrants such consideration. At that juncture, humanity would become a subject of interest, and direct contact might then be deemed appropriate. Thus, Oumuamua serves as a cosmic Turing test, an evaluation of humankind's collective intelligence. The pertinent question is whether we possess the intellectual acuity to comprehend that we are undergoing an examination, or if we will dismiss the evidence because it contradicts our ingrained, comfortable narratives. Loeb has been exceptionally vocal regarding the conspicuous absence of a coordinated institutional response. No governmental task force is dedicated to scrutinizing Oumuamua as a potentially artificial construct. There are no established protocols for addressing a confirmed technological origin. Furthermore, there is a distinct lack of international collaboration concerning observation strategies or potential defensive measures. Instead, we observe a scattering of individual scientists pursuing their routine research, augmented by a few individuals like Loeb endeavoring to draw attention to possibilities that the broader community seems intent on disregarding. He has submitted comprehensive white papers to the United Nations, advocating for the formation of an international committee tasked with the assessment and response to interstellar objects. He argues that deferring preparation until definitive proof emerges is an inherently dangerous strategy. If Oumuamua were hostile and were to deploy weaponry upon reaching perihelion, discovering this threat on October 29th would render any preparation tragically too late. It is demonstrably preferable to overreact to the possibility of a comet than to underreact to a potential invasion. The financial and logistical cost of a false positive would amount to some wasted resources and a degree of mild public embarrassment. The consequence of a false negative, however, could be the existential termination of civilization. The inherent asymmetry of risk necessitates a cautious approach, even when confronted with threats of low probability. The media has played a significant role in amplifying Lowe's message through interviews, articles, and television appearances. He has effectively become the public spokesperson for the artificial origin hypothesis, thereby providing him with a platform to disseminate awareness. However, this prominence also renders him a target. Critics accuse him of seeking personal notoriety, of undermining the credibility of legitimate SETI research, and of impeding serious scientific endeavors by associating them with sensationalism. Lowe's response remains unwavering. He asserts that scientific inquiry must diligently pursue evidence, irrespective of its origin or implications. If the evidence suggests that an artificial source is a plausible explanation, then that possibility warrants rigorous investigation. To dismiss it outright without due examination, simply because it is discomfiting or deviates from conventional thinking, constitutes not science, but rather dogma. He maintains that humanity should aspire to a higher standard of intellectual engagement. October 29th represents his critical juncture. Should Oumuamua disintegrate at perihelion in a manner consistent with a typical comet, his estimated 40% probability would be deemed excessive. The observed anomalies, while intriguing, would then be attributed to natural explanations that would eventually be elucidated. His reputation would suffer a setback, and life would proceed as usual. Conversely, if Oumuamua survives perihelion intact, or if it deploys auxiliary objects, or if it exhibits clear evidence of technological construction, his 40% assessment would be validated as prescient. He would be recognized as the scientist who accurately foresaw the situation when others failed to do so, the individual who perceived what many refused to acknowledge. If an intermediate outcome occurs, where the object remains ambiguous even after its perihelion passage, the debate will undoubtedly continue. This would necessitate further observations, additional scholarly papers, and prolonged argumentation, with the uncertainty persisting until definitive evidence emerges one way or the other. Lowe appears to be at ease with this prospect. He is not making claims of absolute certainty. Rather, he is advocating for the serious consideration of the possibility. A 40% probability is distinct from a 50% chance. It signifies less than half. He is essentially stating that while a natural origin is statistically more probable, the artificial probability is sufficiently significant to preclude responsible dismissal. This perspective is, in fact, a rather reasonable framing of the situation, devoid of sensationalism. It does not assert definitive proof, but rather suggests that the available data compels consideration of both potential outcomes and preparation for either eventuality. The crucial question then becomes, is such preparation feasible? What course of action should be adopted when one posits a 40% probability that an interstellar object might behave unexpectedly at perihelion? The immediate response would involve exhaustive observation, utilizing every available instrument. Efforts to establish communication would be initiated, involving the transmission of radio signals, optical pulses, and mathematical sequences to ascertain if a response is forthcoming. Trajectories would be meticulously calculated to predict the destinations of any deployed objects. The assessment of defensive capabilities would be undertaken. What tangible actions could humanity realistically execute if a hostile entity were to emerge? The probable answer to this final query is a dishearteningly limited one. We possess no weaponry capable of reaching Oumuamua at its current celestial position. We lack spacecraft that could effectively intercept fast-moving objects deployed from it. Planetary shielding technology is non-existent. Our capacity for defense against an interstellar threat is, for all practical purposes, zero. Consequently, if Lowe's assessment is correct and Oumuamua is indeed hostile, humanity would find itself entirely defenseless. We would be relegated to observing, documenting, and experiencing whatever unfolds, with the faint hope that its interstellar originators harbor no malevolent intentions. While hope is not a viable strategy, it may regrettably be all that remains at our disposal. The low scale, the 40% probability estimation, and the Turing test hypothesis collectively represent Lowe's concerted effort to introduce a modicum of rationality into a discussion concerning a possibility that most individuals find exceedingly difficult to contemplate: the visitation of extraterrestrial life, the arrival of technology from another star. First contact, in this scenario, is not occurring through the conventional SETI method of radio wave detection, but rather through the physical presence of an object within our solar system. If his hypothesis proves incorrect, he will serve as a cautionary example of the potential pitfalls when intelligent individuals become overly captivated by exotic explanations. Conversely, if he is accurate, he will be remembered as the scientist who attempted to issue a warning that went unheeded. Regardless of the ultimate outcome, the truth will soon be revealed. The countdown continues, with October 29th merely days away, and Lowe's 40% gamble is poised to be confronted by the unyielding force of reality. The countdown has commenced. What lies ahead? We are now in the final days. It is October 21st, and as you are hearing this, there are 8 days remaining until perihelion. 8 days until Oumuamua reaches its closest proximity to the Sun. At that juncture, we will ascertain whether Harvard's concerns were warranted, or if this entire episode has merely been an elaborate instance of pattern recognition within natural phenomena. The observation schedules have been meticulously arranged, involving multiple missions, a diverse array of instruments, and a coordinated effort spanning various space agencies and research institutions. Every entity capable of directing a telescope or a spacecraft sensor toward Oumuamua is poised to do precisely that. This is because, irrespective of what transpires at perihelion, it is imperative that we witness and comprehend it. This event represents the pivotal moment that will shape our understanding of this object. Let us now proceed through the established timeline, detailing the critical dates for observations and the potential knowledge to be gained from each. From October 29th to the 30th, perihelion occurs. Oumuamua will achieve its closest approach to the Sun, situated at an astronomical unit of 1.4, equivalent to approximately 210 million kilometers, positioning it just inside the orbit of Mars. During this period, the object will be subjected to the maximum solar flux, with an estimated 18 gigawatts of power impacting its surface. For a comet, this signifies the peak of its outgassing activity, its greatest brightness, and its highest level of energetic output. For a technological construct, this represents the optimal moment for any orbital maneuvers. This is when maximum velocity and efficiency for any trajectory alteration would be achieved. We will not be able to directly observe perihelion due to the obscuring glare of the Sun from Earth-based telescopes. The object will be on the far side of the Sun, hidden from our direct view. However, spacecraft in the vicinity might capture fleeting glimpses. The Parker Solar Probe is currently traversing the inner solar system. While its trajectory will not bring it into close proximity with Oumuamua, its instruments could potentially detect the object if it exhibits a significant increase in brightness or expels a substantial amount of material. SOHO, the Solar and Heliospheric Observatory, is stationed at the Earth-Sun L1 Lagrange point. It continuously monitors the Sun. Should Oumuamua transit the solar disk or pass sufficiently close to be captured by SOHO's coronagraph, we would obtain an observation. This would likely be a brief glimpse, yielding limited data, but nonetheless valuable. What specific phenomena are we scrutinizing at perihelion? Firstly, fragmentation. If Oumuamua is composed of a loosely bound cometary nucleus, the immense tidal and thermal stresses encountered could cause it to fracture. Such fragmentation events have been observed previously, as with Comet Ison in 2013 and Comet Shoemaker-Levy 9 before its impact with Jupiter. Comets are not always capable of withstanding close solar passes. Their structural integrity is contingent upon their internal composition and construction. If Oumuamua fragments, this would constitute compelling evidence for a natural origin. Conversely, artificial constructs are engineered with structural reinforcement to withstand significant stress. They do not typically disintegrate spontaneously. Secondly, the brightening curve. We will meticulously observe the degree to which the object intensifies in brightness as it approaches perihelion. Natural comets exhibit predictable brightness variations correlated with their distance from the Sun and the volatility of their constituent materials. If Oumuamua adheres to these established curves, a natural explanation would be strongly supported. Deviations from these expected patterns, such as significantly greater or lesser brightening, or the occurrence of irregular fluctuations, would be highly intriguing and necessitate further explanation. Thirdly, trajectory deviation. Any alteration in velocity that cannot be attributed to the predictable forces of gravity and solar radiation pressure would be a critical indicator. Even minor deviations are significant. A change in velocity of only a few meters per second would suggest the application of thrust, thereby signifying active propulsion and irrefutably demonstrating an artificial origin. This is arguably the most crucial measurement we seek, but it demands extremely precise tracking both before and after perihelion to enable a comparative analysis of trajectories. This task is rendered particularly challenging by the object's concealment behind the Sun during the critical observation window. From October 30th to November 6th, the Europa Clipper and Hera spacecraft will traverse the projected path of Oumuamua's ion tail. These missions were not originally designed with Oumuamua as their primary focus. Both are en route to their respective scientific targets: the Moon Europa for Clipper and the Didymos asteroid system for Hera. However, their trajectories fortuitously align with the region where Oumuamua's ion tail is expected to be located, should it possess one. The Europa Clipper is equipped with instruments capable of detecting charged particles, magnetic fields, and plasma. If Oumuamua is actively outgassing and generating an ion tail, the Clipper spacecraft will pass through this phenomenon and conduct measurements of the surrounding environment. This data will provide insights into the composition of the expelled material, its particle density, and the structure of the magnetic field. The Hera mission possesses a less comprehensive instrument suite for data collection, but is equipped with cameras. If the tail is sufficiently luminous and correctly positioned, visual confirmation of its structure and extent may be obtained. These represent passive observations. The spacecraft are not deviating from their planned courses to specifically study Oumuamua. Instead, their opportune locations offer potential data acquisition. Any data, however limited, is preferable to none. On November 4th, a crucial observation window for the JUICE spacecraft is scheduled. JUICE, the Jupiter Icy Moons Explorer, is currently traveling between Earth and the Sun en route to Jupiter. Its trajectory will bring it to within 64 million kilometers of Oumuamua on November 4th. This proximity is significantly closer than most Earth-based observations. It is close enough to facilitate detailed imaging and spectroscopic analysis. JUICE is equipped with multiple cameras, operating in both the optical and infrared spectrums. It also possesses spectrometers designed for compositional analysis and particle detectors for measuring the surrounding environment. This presents one of our most promising opportunities for acquiring high-quality, close-range data on Oumuamua in the post-perihelion phase. Critical questions include: in what condition is the object? Has it remained intact, or has it fragmented? Has its brightness increased or decreased? Has its shape altered? Are there any newly discernible features? Are there any accompanying objects that were not previously apparent? JUICE has the potential to provide answers to these questions, provided its instruments function as designed and its mission controllers can integrate Oumuamua observations into their operational schedule. Their primary mission objectives involve the exploration of the Jovian system. While Oumuamua is considered an opportunistic target with secondary priority, its potential scientific value is considerable. The data acquired by JUICE will not be transmitted immediately. The spacecraft is located at a considerable distance from Earth, on the far side of the Sun, and communication bandwidth is limited. Priority is given to spacecraft health and navigation data. Science data is downlinked as bandwidth permits. The European Space Agency estimates that JUICE's Oumuamua observations will not be available until February of 2026, representing a 3-month delay. This delay, while potentially frustrating, is an inherent reality of deep space communication. Throughout November and December, Oumuamua will re-emerge from behind the Sun, becoming visible once again to Earth-based telescopes. This period marks the resumption of tracking efforts by amateur and professional observers worldwide. Every clear night, utilizing every available telescope, a comprehensive observational record will be compiled to document any changes in the object following its perihelion passage. We will be meticulously examining tail development. If Oumuamua is indeed a comet, we would anticipate the presence of prominent dust and ion tails by this time. The solar wind and radiation pressure would have had sufficient time to generate substantial tail structures, which should be readily apparent even through modest instruments. The absence of such significant tails would imply either minimal outgassing, which would be anomalous for an object that has recently traversed perihelion, or that it is not a conventional comet. We will also be scrutinizing brightness variations. Did perihelion result in the expected increase in luminosity? To what extent does its brightness curve align with cometary models, or is it exhibiting aberrant behavior? We will be investigating its morphology, its shape, and its structural integrity. Has it maintained its elongated form, or has it undergone changes? Are there new features? Have there been alterations in the forward jet or the anti-tail structure? Critically, we will be searching for companion objects. If Oumuamua deployed miniature probes at perihelion, these would gradually separate from the main body over time. The solar tidal forces would progressively widen their trajectories. By late November, assuming the probes were released with even modest initial velocities, they would have achieved sufficient separation from Oumuamua to be discernible as distinct objects in high-resolution imagery. This would manifest as multiple points of light rather than a single entity. Such a discovery would be definitive, providing conclusive proof of deployment and substantiating the mothership hypothesis. On December 19th, Oumuamua will achieve its closest approach to Earth, passing within 269 million kilometers of our planet, approximately 1.8 astronomical units. While still a considerable distance, it is close enough to facilitate exceptional observations from Earth. Every major observatory will be engaged in monitoring the object. Radio telescopes will be actively listening for potential signals. Optical telescopes will be employed for imaging its structure. Infrared telescopes will measure its thermal distribution. Spectroscopes will analyze its composition. This represents our most significant opportunity for detailed characterization of the object from Earth. If Oumuamua is transmitting signals, we should be able to detect them. Furthermore, if it is an artificial construct intending to communicate, its closest approach to Earth would represent the most logical time to do so, requiring minimal transmission power and maximizing signal strength for reception. If a message is to be received, December 19th is the anticipated date. SETI instruments will be specifically tuned to detect narrow-band signals, modulated carriers, or any signature that deviates from the natural background noise. This type of search has been conducted for decades, directed at distant stars. Now, a target exists within our own solar system, close, luminous, and potentially technological. If SETI is ever to yield a positive result, this may be the occasion. On March 16, 2026, Oumuamua will pass within 54 million kilometers of Jupiter. This proximity will enable observation by the Juno spacecraft. Juno is currently in orbit around Jupiter, with its instruments primarily designed for studying the giant planet, its magnetosphere, atmosphere, and internal structure. However, these instruments can be reoriented. At a distance of 54 million kilometers, Oumuamua remains observable by Juno. Juno is capable of performing ultraviolet spectroscopy, infrared imaging, and particle and field measurements. If Oumuamua exhibits any interaction with Jupiter's magnetosphere, Juno will undoubtedly detect it. Should the object emit radiation or particles, Juno will be able to measure them. If new structural features or companion objects have emerged by March, Juno will be able to image them. This potentially represents our final significant opportunity for observing Oumuamua. Following its flyby of Jupiter, it will embark on its outward journey, returning to interstellar space, receding from the Sun and Earth. Eventually, it will fade from view, becoming too dim and too distant, lost against the cosmic background. If its nature remains undetermined by March of 2026, we may never definitively know. Therefore, we have a sequence of events, a carefully planned timeline, with specific dates for observations and the potential resolution of specific questions. This is not a matter of vague speculation. It is meticulously planned scientific endeavor, featuring scheduled observations, established technological capabilities, and clearly defined objectives. The preparatory work has been accomplished. Now, execution is paramount. We must collect the data and ascertain the truth. Between each observational window, continuous analysis, comparison, and refinement of models will take place. Scholarly papers will be published. The scientific community will engage in debate, with interpretations potentially clashing, leading to the gradual formation of consensus or its absence, depending on the evidence presented. This is science unfolding in real time. Hypothesis testing conducted at the velocity dictated by orbital mechanics, slower than we might prefer, yet demonstrably faster than historical astronomy ever achieved. Consider the magnitude of what we are attempting. We are striving to determine whether an object originating from another star system is a natural phenomenon or an artificial creation. We are endeavoring to answer one of the most profound questions humanity can pose. Are we alone? This pursuit involves the utilization of telescopes, spacecraft, and mathematical models, employing the rigorous scientific method underpinned by skepticism and meticulous measurement. This is where humanity excels as a species. Our strengths lie in pattern recognition, tool utilization, and systematic investigation. If an answer exists, we are poised to discover it. However, there remains the possibility that we may not find a definitive answer. There is a chance that Oumuamua will remain an enigma, neither unequivocally natural nor clearly artificial, residing in an uncomfortable state of ambiguity where definitive conclusions cannot be drawn. In such a scenario, different observers might reach divergent interpretations based on the same data, and the mystery would persist because reality fails to provide clear-cut resolutions. In certain respects, this would represent the most unfavorable outcome, worse than a confirmed comet or a confirmed spacecraft, because it would leave us perpetually ensconced in uncertainty. We would remain forever wondering, forever debating, never truly knowing, with the fundamental question unresolved and the mystery enduring indefinitely. We are meticulously tracking an object as it traverses space, observing its movement, quantifying its properties, and endeavoring to comprehend its identity and purpose for being here. In 8 days, it will reach perihelion, potentially performing an action that will reveal its true nature. Within 3 months, we will obtain our most detailed close-up images. In 5 months, we will have one final opportunity for observation before it departs. This constitutes our limited window of opportunity. Beyond that point, Oumuamua will be gone, and we will be left solely with the data we have managed to collect and the conclusions we can derive from it. The countdown intensifies. October 29th draws nearer, and somewhere beyond the sun, concealed from our view, Oumuamua is experiencing conditions unlike anything it has encountered in billions of years. It is subjected to heat, light, and gravitational forces, undergoing a test of its composition, its design, or its evolved capabilities. This is the critical moment. This is the ultimate test, and we are on the precipice of witnessing its results.